Okay, let's start the session. So, hello everyone, welcome. I hope you all are doing good. I am Sambhav, your senior math instructor. Today in this session, we are gonna talk about very important topic, that is trigonometry. Correct? Very important, even from your exam point of view, right? Now, in this session, we are gonna talk about the basics of trigonometry. The chapter name is Introduction to Trigonometry in your books, and then in the next session we are going to talk about the advanced part of it, like the how to find the values of different angles or even different type of problems we are going to see in the next session. So this chapter has been divided in two equal parts. So the first part is all about the introduction. So as I told you that in this session we are going to talk about trigonometry. So in this particular session basically we are going to talk about the introduction part of it, then trigonometric ratios. What are trigonometric ratios? Then we are going to summarize this. So, and in the next session, as I told you that I will be giving you advanced knowledge, how to solve different problems and everything. Now, what is trigonometry? First, we need to understand what is trigonometry, why the name and everything. So, trigonometry is a branch of mathematics, of course it is, that studies the relationship. Look at the wordings here, that studies the relationship between angles and sides of a triangle. In a triangle, the main basic three components are sides, angles, and vertex. Correct? So here we are discussing a very specific relationship between angles and the side lengths. Now, particularly in a right angle triangle. So most of the time in your class, we are going to discuss the trigonometry based on right angle triangles only. Now, the word trigonometry comes from, so this word is not a single word, it's a combination of two words. First word is trigonon. So what is the meaning of this word? Triangle. As I told you that this has something to do with triangles only. So this trigonon means triangle itself. Then the second part is metron. Metron means measurement. This word you may have seen in geometry also. Geometron. It means study of the geography or the earth. So the same concept is applied here. Trigonon metrons means study of the measurement of triangle. And very specifically, we are going to study the relationship between the angle and the side lengths of a particular triangle. And in this class, you don't need to be worry about too much of this chapter, because basically we are going to consider right angle triangles, and it is very easy. You may find it hard because this has been introduced for the first time in to you, the trigonometry. That's why it will sometimes feel overwhelming, but it is not. This is very easy. Now, so trigonometry means measurement of triangles. Now, this is about the name and how it came, correct? Now, why do we study trigonometry? Why this is important? Now, trigonometry helps us in measuring heights and distances without physically measuring them. Look at the wordings. Measuring heights and distances without physically measuring them. Now, this is very broad idea. Now, let me ask you one thing. We know what is the height of the Mount Everest, correct? The highest peak. What is the height? We know this, correct? How do we know this? Is someone measuring it using measuring tape? Do they have any tool which they are using to measuring it physically? How are they coming up with the numbers that this is the actual height of Mount Everest? So there was a man named Sir George Everest. So he came up with an idea that we should use theodolites. Theodolite, again a new term to you. Theodolite is a measuring tool which is used to do surveys and everything. It can use trigonometric ratios to find the distance or height of something. So at that time, Sir George Everest, with the help of his team, built two largest theodolites that world has ever seen. Then he placed them at certain distance from the Mount Everest. Then he used trigonometry to find the height of the Everest. That's why the name of the Mount Everest is after him, Sir George Everest. Correct? Those two theodolites are still present in one of the museum in India itself, in Dehradun. So if you want, you can see that also. Those two theodolites are there. Now we have modern theodolites and everything, but still we are using theodolites to do surveys and everything. Now we can use heights and distances we can use trigonometry to find heights and distances without physically measuring them. He is not physically measuring the height of the Mount Everest, correct? He is using a equipment from two sides, and then he is using trigonometric ratios or concept of similar triangles to find the height. Now, understanding the navigation, astronomy, engineering and architecture. So trigonometry is having very advanced use actually. Very vast use of trigonometry is there in this world. So we are using it for navigation, astronomy, engineering and even architecture. So in every branch it is used in some way or another. When you are gonna reach higher classes, you are gonna see that trigonometry will appear in other subjects also, like majorly in physics. Then solving problems involving angles and distances. This is also one of the application. And there is one more interesting application of this chapter. What is that? That we can score easily in the exam, correct? Now, so these are basic applications of trigonometry, although it has a very vast or huge amount of applications. Now, real life examples. What are some real life examples? One example I gave you about Mount Everest. Then we have how can we find the height of a tower without climbing it. Suppose if we are having a tower and if we are afraid of heights, we don't want to climb it, but we want to know the height of that tower, then we can do what? We can use trigonometry. The next chapter after introduction to trigonometry is heights and distances, correct? Or some applications of trigonometry. There you will be seeing the real life applications of trigonometry, correct? You may have seen examples also that some pole is there, it is casting a shadow, one balloon is flying, one kite is flying, and these examples, correct? How can we find the height or distance without physically measuring them? We can use trigonometry there. Then, how do pilots calculate altitude? Suppose a pilot is flying a plane or aircraft or anything, then how can they find the height at what altitude they are at? They can use trigonometry. Then, how does a surveyor measure the width of a river? As I told you that there are surveyors who are doing survey regarding land, rivers and everything. So they are not measuring everything, no, physically. They must be using some kind of equipment. So those equipments are based on trigonometry. So these are some real life examples. So if you know any similar example, you can let us know in the chat box also. Now, as I told you that this chapter in your class is all about trigonometry dependent on right angle triangles. So first we need to remind ourselves what are right angle triangles, correct? We know them, but let's remind ourselves. Right angle triangle means one of the angle is having exact 90-degree measure, correct? If in any triangle one angle is having exactly 90-degree value, then that triangle is known as right angle triangle, because 90-degree angle is known as right angle, correct? So if one of the angle is exactly 90-degree, then that triangle is known as right angled triangle. According to angle sum property, we know one fact that the sum of all the angles inside a triangle will always be equals to 180-degree. If one of the angle is exactly 90-degree, can there be any other angle which can be equal to or greater than 90? No, it is not possible. Suppose this angle is 90-degree, huh? Then sum of other two angles would be 180-degree minus 90, 90 itself. So even if this is 1 degree, then it will be 89. So not greater than or even equals to this angle. So this is the highest value. If a 90-degree angle is there, then it is the highest angle present in that triangle, correct? Now, if it is the highest value present in that triangle, then we know for a fact that in case of any triangle, the larger the value of the angle, the greater the length of the opposite side of it. correct? If it is the highest value among the angles, then the side opposite to this angle would be having the greatest length or largest value of length, correct? So this side is the opposite side of this angle B or 90-degree. Then AC is the longest side. Now, if AC is the longest side, then it is having a very particular name, and the name is hypotenuse. So hypotenuse is that side which is opposite to the angle that is exactly 90-degree. Also, it is the longest side present in a right angle triangle. One thing. Now, if we are having hypotenuse, are we having names for other sides also? Yes, we can call them using base and perpendicular, but it depends on what angle we are considering. I will explain this concept also, but understand the basic terminology for now. Base is the side adjacent to the reference angle. Whatever angle I am considering other than this, because we are done with the 90-degree angle, so we are left with two angles now, either angle A or angle C. Depending on which angle we are referring to, we can have base and perpendicular differently. Base is that side which is adjacent to the angle itself. Suppose if I am considering angle C, then the side adjacent to angle C are AC and BC, correct? But it's AC, done, because AC is the longest side, hypotenuse. Then the only adjacent side that is left is BC. It means it is the base now. Then side opposite to this angle C is known as perpendicular. So third side, perpendicular, side opposite, one sec, side opposite to the reference angle. Now let me ask you one thing. Suppose if I am referring to this angle A, will AB be the base or BC? AB is the base. Why? Because this angle A is having two adjacent sides. AC, already we know that it is hypotenuse, and then AB. So base is what? Side adjacent to the reference angle. So AB is the base now. Then what is perpendicular? When we are considering angle A, perpendicular side is BC now, the side opposite. Correct? Now, what are trigonometric ratios? First thing, when I told you that trigonometry is the study of relationship between angles and the sides, so what does it mean? It means that we are going to establish a relationship between the angle value and the side lengths, correct? But side length can vary, correct? Suppose if I am having two different triangles, the value of angle can be equal, correct? Value of angle can be equal, but depending on the size of that angle or triangle, the side lengths can be different, correct? So we cannot directly consider the side length. We need to deal in terms of ratio now. Why ratio? Because ratios can be simplified further, correct? Even if we are enlarging a triangle in same proportion, then the value of the side lengths is gonna change, but the ratio of the sides will never change, correct? So that's why we are using the term ratios here. Otherwise, it would have been trigonometric lengths or trigonometric sides, correct? Why ratio is there is because we cannot consider the length exactly as it is. Otherwise, we need to deal with very large amount of data depending on the different side lengths, correct? But we are going with ratios now. So this way we can solve this problem even if we are having different lengths in a triangle, but we can deal with them easily because we can find the equivalent ratios. Now, trigonometric ratios are ratios of the sides of a right angle triangle. So the ratios is of sides now. Angles can be equal, so no need to find the ratio of angles, but we can find the ratio of the side lengths. It means we are dividing at least two sides. We are writing them in a fractional form, correct? So it can be AB by BC, it can be AB by AC, BC by AC, like that, or reciprocals also. Now, with respect to a given angle, so whatever angle we are considering, depending on that angle, we can have different base, different perpendicular, correct? Depending on different base and different perpendicular, we can have different trigonometric ratios value. I will explain this in detail. They depend on the angle. What is the value of the angle, correct? Then the ratio, not the actual length. I told you what is the reason behind not using the actual length. If we are using actual length, then we need to deal with very large amount of data, and that will not always be very accurate. So that's why we are going with the ratio thing. We are gonna talk in terms of ratio of two sides. Now, why ratio? If two triangles have the same angles, then their sides are in proportion, correct? Suppose two triangles are there and they are having different sides, but the internal angles are having same measure. The corresponding angles are having same measure, such as uh, 30 30, 60 60, and 90 90, correct? So all the corresponding angles are in same ratio. In sixth chapter of your class, the triangles, you may have understood the concept of similar triangles, correct? Then according to similar triangles, if two triangles are having all the corresponding angles equal, then the two triangles are similar to each other, or it means that their corresponding sides are in the same ratio. So this concept we are applying here. That's why we are going with the ratio. So trigonometric ratios depends only on the angle, not on the size of the triangle. You can increase the length of the triangle, increase the side lengths, but if the angle value you are not changing, then they will always remain in the same proportion, correct? Now, this concept that I explained, now I explain again. Depending on which angle we are referring to, we can have different base or perpendicular value. So other than base perpendicular, we can also refer them as side opposite or side adjacent. So there are two ways to referring the sides now. You need to understand both of them. Now, hypotenuse will remain hypotenuse, the longest side, correct? Side opposite to the 90-degree angle is hypotenuse. Then suppose in this figure I am referring to angle A. Triangle is triangle ABC. B is right angle. So AC is the hypotenuse. Correct? I am referring to angle A now. Then as I told you that for angle A there are two adjacent sides. AC already hypotenuse. Then the other side is AB. So this will be called as side adjacent to angle A. Correct? Then the side opposite, which is not adjacent with this angle A, is known as side opposite to angle A. Now, this is when we are referring to angle A. Suppose if we are referring to angle C, will it be same? The side adjacent will remain same only? No, it will not. It will change now. Hypotenuse will remain the same because hypotenuse is not changing. AC is again side opposite to the largest angle B. So now, if angle C is given or angle C is what we are referring to, then the side adjacent would be BC, because this is already hypotenuse. Then BC is the side adjacent now to angle C, and side opposite to angle C would be AB. So you need to just realize this. Again, if side opposite to angle A is BC, then BC is the perpendicular when we are talking about angle A. If side adjacent to angle A is AB, then AB is the base in this case. And in this case, it is exactly the opposite. If we are referring to angle C and BC is the side adjacent, then it is the base side. And what is the perpendicular side? Side opposite. Very basic concept, correct? Now, these are trigonometric ratios. So initially, I guess Aryabhatta was the one who referred to this sine value first. So Aryabhatta was the one who gave the sine value. He told that the value of sine will always be equals to perpendicular by hypotenuse. In Sanskrit, they are known as Jaya, Trijya, like these words. So he referred them in such a way. Then later on, they named it as sine. but according to Aryabhatta it is Jaya, I guess, if I'm not wrong. But Aryabhatta was the one who gave away this concept first. Then later on they built these cosine, tangent, cosecant, secant and everything. Majorly there are only three trigonometric ratios: sine, cosine and tangent. These three are nothing but the what should I call them? Uh, I'm forgetting the name. Okay, I will remember the name again. But these three are the mean ratios, and you will understand why also. Sine is the relationship between the angle with which side perpendicular divided by the hypotenuse. So depending on what angle you are referring to, sine value will always be perpendicular by hypotenuse. Now look at this triangle ABC, right angled at B, correct? So this is 90 degree. Let me change the color of the pen now to black. So right angled at B. So this is 90 degree angle. Then side opposite to 90 degree angle is the hypotenuse. So it means AC is the hypotenuse. I will use the initials only. H for hypotenuse, B for base, P for perpendicular. Okay. Now, so this is hypotenuse. Then suppose if I'm referring to angle C as the angle, then sine value SINE is the proper word, but when we are writing, we can use SIN with the theta or whatever angle. It can be A, B, C, not B. It can be A, C, or it can be alpha, beta, gamma, anything. Now, you can write it like this, SIN and the angle name. So, if we are going with angle C, then perpendicular by hypotenuse will be the sine. What is perpendicular now if we are referring to angle C? Perpendicular is the side opposite to the referred angle, correct? Which side is the opposite side to this C? This AB. So, this is perpendicular. Then which side is base? BC. So BC is the base. Then what is sine theta if we are referring to angle C? P by H or AB by AC. Then cosine, complementary angle of sine. So cosine is basically complementary angle of sine. We know the concept of complementary angles, no? When two angles are having exactly measure or sum equals to 90 degree, then they are known as complementary angles. Now, look at this triangle, right angled, correct? One of the angle is 90 degree. Then this angle and this angle, are they complementary to each other? Yes, they are, because their sum will always remain 90 degrees, always. Now, this concept later on used to develop the other three trigonometric ratios. So sine is there, then someone thought about the complementary of sine, it became cosine, usually written as cos. You are gonna write COS along with theta or whatever angle you are referring to. And what is the value of cos then? Base by hypotenuse. What is happening here? How come it be base by hypotenuse? As I told you that cosine is the complementary angle of sine, correct? Suppose if someone is considering or referring to angle C, then what is the complementary angle of angle C here? Angle A, correct? What is the sine value for this angle A? That would be perpendicular, but according, if we are referring to angle A, then the perpendicular is BC and hypotenuse is AC, correct? Now, but angle A is the complementary angle of angle C. So if we are finding the trigonometric ratios in terms of complementary angles, then the complementary of sine will become cosine, cos. So cos C value will be same, BC by AC. But now I can see C here, no? And with reference to C, BC is not the perpendicular, it is the base. So that's why cos value will always be base by hypotenuse. Because if I am finding the sine value in the corresponding angle, then the base will be different. So that's why cos is base by hypotenuse now. Then tangent. What is tangent? Tangent is basically the ratio of sine and cosine. Sine divided by cosine. Okay, let's do the math now. If I am saying that tangent is sine divided by cos, so let me do it. Tan theta is sine theta by cos theta. This is the value, correct? Sine theta is P by H and cos theta is B by H, base by hypotenuse. H and H we can cancel. So what are we left with now? P by B. So that's why the value of tan theta or tangent theta is perpendicular by base. Depending on what angle you are referring to, the ratio of perpendicular by base will always give you tan theta. Suppose if we are considering or referring to angle C, then perpendicular to angle C is AB and base is BC. So tan theta would be AB by BC. Now these three are the main trigonometric ratios. Other three are nothing but the reciprocal of these ratios, like cosecant. Cosecant is the reciprocal of sine theta. So cosecant value is 1 by sine theta, or in terms of side ratio, it would be what? 1 by perpendicular by hypotenuse. 1 divided by any fraction, we need to take the reciprocal of the fraction, correct? So the fraction will become hypotenuse by perpendicular. So cosecant theta is hypotenuse by perpendicular. Then secant theta is nothing but the reciprocal of cos theta. So secant theta is 1 by cos theta. Cos theta is base by hypotenuse. 1 divided by base by hypotenuse will become hypotenuse by base. So secant theta is h by b. Cotangent is reciprocal of tangent. So what is the value? 1 by tangent. Tangent is perpendicular by base. So 1 by p by b is gonna give us b by b or base by perpendicular. These 6 are the trigonometric ratios that you are gonna deal with in your whole life. If you are dealing with trigonometric ratios, then you must be dealing with them only. Majority of the time, you are not gonna write their full names. You are gonna use them in short form, like sine theta, cos theta, tan theta, cosec theta or cosecant theta, secant theta, and cot theta. These are the names that you will be using. Now, there is a memory trick to remember this. There are multiple tricks, but you can go with this also. That is, some people have curly brown hair till painted black. Why this is a memory trick? Look at the initial of each word. Some people have. I did color them in a single color, blue, so that you can see easily. Now, some represent S. People have is P and H. So S is equals to P by H. You need to understand it like this. What does S stands for? Sine theta. S is sine theta. What is P? Perpendicular. What is H? Hypotenuse. So sine theta is perpendicular by hypotenuse. Then look at this one. Curly brown hair. It means C is equals to B by H. What does C stands for? Cos theta. So cos theta is base by hypotenuse. curly brown hair. Then third part, till painted black, means T is equals to P by B. T stands for tan theta. Tan theta is perpendicular by base. What about the other three? The three that we are left with. We know that cosecant theta is 1 by sine, correct? Easy. Then secant theta is 1 by cos, and cotan or cot theta is 1 by tan. Now you can remember easily. So the trick is, some people have curly brown hair till painted black. So we are going to use the initial of each word in a pair of three. So three words. So S, P, H. It means S equals to P by H. Sin theta is equals to perpendicular by hypotenuse. C, B, H. C is equals to B by H. Cos theta is equals to base by hypotenuse. T, P, B. Tan theta is equals to perpendicular by base. This is the trick. Remember this. If you want, you can take the screenshot also, so that it will be very much helpful for you, or take a note of it. Very easy to remember. First problem is, in a right angle triangle ABC. Okay, right angle triangle is given to us. Sometimes the figure will be given, sometimes it will not be given. So you can do one thing, you can always create a figure on your own for your reference only. Figure will give you more confidence. What you are dealing with, you can visualize easily. So always do this thing. If you are ever confused what to do now, how to approach the problem, first create the figure. Okay, if it is not given. Then right angle at B, okay, so B is the right angles, and then which side is the hypotenuse? AC, the side opposite to right angle. Now AB is equals to 6 centimeter. Okay, length of AB is given to me 6 centimeter. BC is also given to me 8 centimeter. We need to find sine A, cos A, tan A. Now this is very easy problem. If you are thinking how to find this, or how should we approach this, then first thing, what things do we need when we need to find these trigonometric ratios? What are the things we need? First thing, sine A is, let me write, sine A means that we need to find the ratios of those sides which are referred when we are considering angle A. So sides we need to consider when we are referring to angle A, because sine A means we are considering angle A, and sine value will always remain same depending on what angle we are considering, the perpendicular by hypotenuse of the triangle. So which angle we are referring to? Angle A. So let me put a mark here. Now it is perpendicular by hypotenuse. Which side is perpendicular when we are referring to angle A in this triangle? Okay, this AB is the side adjacent, correct? Adjacent side. So adjacent side will always be base. So this is base. Then perpendicular side would be side opposite. So this side is perpendicular, BC. Okay, length of perpendicular we know. What about hypotenuse? Do we know the length of hypotenuse? No, it is not given directly to us. Why I am saying not given directly? Is there any way that we can find this length? Yes, we can find this very easily. We know the concept of Pythagoras theorem, correct? So, according to Pythagoras theorem, the square of the hypotenuse in a right angle triangle will always be equals to sum of the squares of other two sides, correct? So first, let's find the value of hypotenuse here. According to Pythagoras, one second, let me erase this. First, we are going to find the length of hypotenuse using Pythagoras theorem. So hypotenuse square will always be equals to square sum of squares of other two sides. It means h square is equals to p square plus b square. These two values we know, 6 centimeter, 8 centimeter. So perpendicular is 8 centimeter. So 8 square, base is 6 centimeter, 6 square. 8 square 64, 6 square 36. Sum 100. But this is not h, this is h square. Correct? Then what is the value of h? Under root 100. Do we know the value of root 100? Yes, 10 centimeter. So it means hypotenuse is 10 centimeter. Now we know everything, correct? So let's erase this. Now we can easily find the ratios. So the first part here is, if a problem like this is given to us, so first we need to calculate the remaining side. Sometimes examiner can give you the value of base and perpendicular, so you need to calculate the value of hypotenuse. Sometimes he can give you the value of hypotenuse and one of the other side, then you need to calculate the remaining one. So the formula will remain same, Pythagoras theorem, h square will always be equals to p square plus b square. So whatever side is not known to you, you can calculate easily by transposing the terms accordingly, correct? Now we know all the values. So sine theta or sine A in this case would be P by H. Perpendicular BC, hypotenuse AC. Length of BC 8, length of AC 10. But this can be simplified further, correct? So the final value would be 4 by 5. So sine A is 4 by 5. Easy, correct? We just need to find the length of hypotenuse, then we can easily find the sine. Now, cos A. Remember, some people have SPH, some people have curly, means cos, brown hair. So, cos A would be B by H or base by hypotenuse. If we are considering or referring to angle A, then base is AB. AB, hypotenuse is hypotenuse AC. Length of AB 6, length of AC 10. But this can be simplified further. So 3 by 5. Because these are having one common factor 2. So we can eliminate that and we are left with 3 by 5. Now to find tan A, there are two ways. As I told you, tan A is nothing but the ratio of sine A by cos, correct? So that way also we can find, or otherwise we can use the ratio directly. Some people have curly brown hair till T, painted P, black B. So tan A is P by B, perpendicular by base. Perpendicular 8 centimeter, base 6 centimeter. But this can be simplified further, correct? So 4 by 3. Even if we are going with sine theta by cos theta, then 4 by 5 divided by 3 by 5. 5 and 5 cancel. We are again left with the same answer, 4 by 3. So there are two ways to find the value of 10, but my suggestion would be that go with this. Tan A is equals to P by B, correct? So this way you can approach this problem and you can find the solution. First you need to find the value of hypotenuse, then only you can move ahead, correct? Now, if sine theta is equals to 5 by 30, where theta is acute, find cos theta and tan theta. Now, different type of problem, but we need to find the trigonometric ratios again. But here the problem has been written differently. Value of sine theta is given to us. Now it is asking us to find the value of cos theta and tan theta. What is sine theta? Some people have S is equals to P by H. So sine theta is equals to perpendicular by hypotenuse. Value is already given 5 by 13. So we can relate, correct? So 5 is value of P, 13 is value of H. So suppose this is the angle, this is theta, huh? The perpendicular with reference to angle C is what? AB. AB is 5. Please don't write centimeter in front of 5. Why? Because this is not the exact length. It can be a simplified fraction. This is related to this perpendicular, but this is not the actual length. Or we are not sure that it is the actual length, but this is the ratio, no? So we can use 5, but we cannot write centimeter in front of it. Hypotenuse is 13. When we are enlarging or shrinking a triangle, then their ratio will not change, correct? The concept of similar triangle, but we are not sure if the lengths are exact. But we can use these values to find the other remaining values, that we can. Now, we know the length of hypotenuse, we know the one of the sides. How to find the remaining one? How to find this value? The formula will remain same. H square will be equals to P square plus B square. Means hypotenuse square will always be equals to perpendicular square plus base square, or the sum of the squares of other two sides. Now, this value I know, this value I know, this I don't, but I can easily find, correct? So in place of H, I will write 13 square. In place of B, 5 square plus B, I want to know. 13 square is 169. 5 square 25. B square we don't know. So B square as it is. When transposed to left side, this 25. So it will become a negative term. So 169 minus 25. It will be 144 is equals to B square. Which suggests that B is under root of 144, and 144 is the perfect square of 12. So under root 144 is 12. So BC is 12. Now we know all the three sides, correct? Let me erase the unnecessary part from the screen. Of course, you need to write this in your exam sheet and no need to erase from there. Otherwise, an examiner is gonna think that you are cheating and he will deduce some marks. So don't write these from your main mark sheet. Okay. Now we know all the sides, correct? In terms of ratio, not the exact length, but they are pretty much useful. Sin theta we already know. We need to find the value of cos theta. So cos theta is curly black here. B by H. Base value is 12 now, because theta is here, no? Side adjacent is the base, so 12. Hypotenuse is hypotenuse. They are co-primes, it means they are having no common factor. So this is the final answer. What about tan theta? Tan theta is what? Perpendicular by base. So perpendicular here is 5 and base 12. Again co-primes. This is the final answer. So this is how you can approach this type of problems, but be very careful. No need to write centimeter in front of these values because they are ratios, not the actual lengths. But they are pretty much useful in solving this type of problems. If any specific trigonometric ratio is given, then you can utilize that information. Okay. Now, third one. What is given to us now? If cot theta is 7 by 8, we need to evaluate 1 plus sine theta into 1 minus sine theta divided by 1 plus cos theta into 1 minus cos theta. A very different type of problem, but still in exam you can expect anything, correct? But don't worry, this is also very easy. This is even easier than the previous ones. You are gonna help me in this, okay? What is given to us? Cot theta is 7 by 8. We know cot theta is nothing but the reciprocal of tan theta. It means it is 1 by tan theta. Tan theta is perpendicular by base, correct? So it will become 1 by perpendicular by base. Ultimately, it will become base by perpendicular, correct? So cot theta is base by perpendicular, or this ratio that is given to us belongs to b by b. So in this triangle, first we can consider any angle to be theta. Suppose if I am going with this is my theta, then we are looking for this ratio b by p. So base would be BC, then side adjacent, the value is 7, not centimeter, 7, and perpendicular is side opposite, so AB is the perpendicular, value is 8, again not centimeter. Now this information is useful because now we know the value of at least two of the sides. If we know the value of these two sides, can we find the third side? Of course we can. Now let me erase this thing. No need to erase this from exam sheet, huh? So we need to find the length of hypotenuse. According to one of the greatest mathematician, Pythagoras, or one Indian mathematician is also there, Bodhayan, who gave away this theorem, Pythagoras theorem, even before Pythagoras. Hypotenuse square will always be equals to sum of the squares of other two sides, correct? Now h square is p square plus b square, correct? H square we don't know, we need to calculate, so I will keep it as it is. P square is 8 square plus b square is 7 square. 8 square is what? 64. 7 square 49. Sum is 113, right? 60 plus 40, 100. 4 plus 9, 13. So 113. This is value of h square, not h. Then what is h? Under root of 113. Now you must be thinking that it should come in a perfect square root value. It should be something like a whole number, correct? But that is not always the case, correct? If you are getting this type of value, don't worry, this can be the answer. Now we know the length of hypotenuse, this that is in roots. I will keep it in roots only. Under root 113. So let me erase this. Now we know all three sides, correct? Base, perpendicular, hypotenuse. And we need to evaluate, or we need to finally find the value of this. 1 plus sine theta into 1 minus sine theta divided by 1 plus cos theta into 1 minus cos theta. There are two ways. Either I can directly multiply them. How? Because this looks like to me a plus b into a minus b, correct? A plus b into a minus b, identity, that will be equals to a square minus b square. Same goes for the denominator, correct? There also this identity is applicable. Or we can put values first, then we can apply the identity. So which two values do we need? Which two trigonometric ratios do we need here? Sine theta and cos theta. So first let's find the value of sine theta and cos theta. Here I will do this. Okay, sine theta. P by h, perpendicular by hypotenuse. Perpendicular is 8, hypotenuse is root 113. So 8 by root 113. Then cos theta is base by hypotenuse. It means 7 by root 113. Now we know the value of sine theta and cos theta. That is all what we need to evaluate this, correct? Now put the values in the given expression. So the expression will become 1 plus, in place of sine theta, 8 by root 113. 1 minus 8 by root 113 divided by, in brackets, 1 plus 7 by root 113 and 1 minus 7 by root 113. Correct? Now we can apply the identity a plus b into a minus b. It will become a square minus b square. So in numerator, that will be 1 square minus 8 by root 113 whole square. And in denominator, again the same identity is applicable. So a square means 1 square minus 7 by root 113 whole square. Now we can open the squares. So let me split the screen so that we can use this space. 1 square is 1 minus 8 by under root 13 whole square, under root 113 whole square. 8 square would be 64 and square and under root in the denominator will cancel each other. So it will become 1 minus 64 by 113. And in the denominator of the whole expression, 1 square would be 1 minus 7 square 49 divided by under root 113 square 113. Now we can take LCM in denominator and numerator both. So upper side will become 113 minus 64 by 113 and whole divided by, here LCM again, 113 minus 49 divided by 113. We can cancel this value. Anyway, this is problematic. 113 minus 64 is 49 divided by 113 minus 49 is 64. Are they having any common factor? Are they? No. This is your final answer. This problem is very easy, but the main part is that we need to write down too many steps, but that is not a problem, correct? Because these are very easy calculations. So we are just following the previous step to find the other one. Just doing the basic math calculation, square, under root, plus, minus, multiplication, division. That's it. So this is how you can find the value, correct? Even though we are getting the value of h in under root, it is not a perfect whole number, but still we can easily find the answer, correct? Now, next problem. Again, one different type. If 3 cot A is equals to 4, check whether left side 1 minus 10 square A divided by 1 plus 10 square A is equals to cos square A minus sin square A. These type of problems can also be solved using trigonometric identities, which we are gonna discuss in the next session. But they are also solvable using trigonometric ratios. But the ratio is not given to me. The value that is given to me is 3 into cot A is equals to 4. How can we use this to make it a ratio or to find the ratio, the length of sides in terms of ratio? First thing first, if you are getting confused, then draw the figure. Any triangle you can draw, right angled triangle. Suppose this is A, B, C. What do we understand by 3 cot A is equals to 4? When the value of cot A being multiplied with 3 is gonna give us 4. One way of thinking like this. Suppose if I transpose this 3 to right side, what will it become? Cot A is equals to 4 by 3. Now, does it look like a trigonometric ratio? Yes, it is looking like a trigonometric ratio. What is cot A? 1 by tan A, correct? So, it means the value of cot A is base by perpendicular. Okay, this till now I have been considering this angle to be theta, no? So here the angle A is given, so it means we need to consider this angle. Be very careful about this. Whatever angle is given, you need to consider that angle only in the figure. Now, what is the side that is base now when we are referring to angle A? So base is side adjacent, so this is my base. So the value of the base is 4, not centimeter again, very careful. Value of perpendicular side opposite is 3. Can we find the value of hypotenuse? Of course, we know how to find it using Pythagoras or Bodhayan theorem. So that would be h square is equals to p square plus b square. H square is not known to us. We will keep it as it is. P square means 3 square, 9. Directly I am writing, but in your exam, you need to write every step. Huh? B square is 4 square, 16. So h square is 25. H is root 25. We know this, correct? 5. So the value of this side is 5. Anyway, let me give you one hint. If out of these three, any two values are given as side of any right angle triangle, then the other one will always be the missing value. 3, 4 and 5 are nothing but the Pythagorean triplets. They are known as Pythagorean triplets. So if two sides are 4 and 3, then the third one would be 5 only. If two sides are 5 and 4, the 5 and 3, then the third side would be 4 only. For 5 and 4, the third side would be 3 only. They are Pythagorean triplets. Now, we know all the side lengths, not the exact values, but their ratios, correct? So now how to approach this? One second, I need to erase everything so that we can move ahead. Second. We need to verify this relationship, correct? So if we need to verify this relationship, first I need to find the values of tan. Here only tan is needed, and here cos and sin. Now let's find the values. I'm gonna write the values here. I'm gonna use this space. So tan A perpendicular by base. So it means 3 by 4. Sin A perpendicular by hypotenuse. It means 3 by 5. Cos A base by hypotenuse. It means 4 by 5. Now we know all the values, correct? So we can put the values here. So first I'm going with left hand side. 1 minus tan square A, it means 1 minus 3 by 4 whole square. Divided by 1 plus tan square A means 1 plus 3 by 4 whole square. This is gonna give us 1 minus 3 by 4 whole square means 9 by 16, correct? 1 plus 3 by 4 whole square means 9 by 16 again. Take the LCM. So the numerator will become 16 minus 9 by 16. Divided by the denominator will become 16 plus 9 by 16. Right? These 16s are cancelable, so we are going to cancel them. So 16 by 9 in numerator, 7, divided by 16 plus 9, 25. So the LHS is 7 by 25. You can write the solution like this only. First, we are gonna solve for LHS. Now, consider RHS. RHS is cos square A minus sin square A. So, cos square A means 4 by 5 whole square minus sin square A means 3 by 5 whole square. 4 by 5 whole square, 16 by 25 minus 3 by 5 whole square, 9 by 25. They are having same denominator, so we can easily perform the operation, correct? So it will become 16 minus 9, that is 7 by 25. Are they equal? Yes, they are. They are equal, correct? So it means this is true. So the given equation is true for all the values of angle A that you need to write in the end. Okay. Now this is one type. Next one. In triangle ABC, right angled at B, if tan A is equals to 1 by root 3, find the value of sin A cos C plus cos A sin C. Okay, now this time we are dealing with a different type of problem. Till now we are dealing with those trigonometric ratios where we are only referring to one angle, correct? If we are talking about angle A, so angle A only. Talking about angle C, so angle C only. But this is the first problem where we are gonna, sorry. So this is the first problem where we are gonna refer to two different angles, angle A and angle C also. So be very careful about the values here. Whatever value of sin A it cannot be always equals to value of sin C because we are having different angles now. But still we can solve this very easily. How? Tan A is given as 1 by root 3. Tan A is 1 by root 3. Now, what is tan A? Perpendicular by base. So it means this is P by B. So tan A means we are referring to angle A, this angle. So with respect to angle A, the value of perpendicular is 1. So perpendicular is side opposite. So this is 1. What is base now? Value is root 3, but with reference to angle A, the base is side adjacent. Correct? Can we find the value of hypotenuse? Yes. So we can use h square is equals to p square plus b square. Now h square would be perpendicular square 1 square plus root 3 square. H square would be 1 plus root 3 square 3. H square is 4. Therefore, h is under root 4, that is 2. Now we know the value of hypotenuse, 2. Now we are done finding all these side lengths, not exactly the length but the ratios, correct? So we can, I will erase this. You don't need to erase this part from your exam sheets. Now we can approach the problem. So what do we need to find? First we are gonna find the values. Prior to solving the equation or expression, we are gonna find the values first. We need sin A and cos C, correct? So I'm gonna write the values here. Sin A. With respect to angle A, we need to find the ratios of P by H. P is perpendicular, so 1 by H, 2. 1 by 2. Then cos A. Cos A with reference to angle A, which side is the base? AB, root 3. Hypotenuse, same, 2. Then we need sin C and cos C. Sin C. Now the angle that we are considering is different. So sin C is, it means we are referring to angle C. Which side is side perpendicular when we are referring to angle C? AB. So sine C would be root 3 by hypotenuse 2. Then cos C. When referred to angle C, which side is the base? BC divided by hypotenuse 2. All the values are known to us now. Now, put them in the expression. Sine A means 1 by 2 into cos C. Cos C is this 1 by 2 plus cos A. Cos A is root 3 by 2 into sine C. Sine C is root 3 by 2. Multiply these two and these two. 1 by 2 into 1 by 2, 1 by 4 plus root 3 into root 3 whole square. So 3 divided by 2 into 2, 4. Having common denominator, same denominator, so we can directly apply the operation. This is gonna give us 1 plus 3, 4 by 4. So the final answer is 1. This is the final answer. And this is how we need to approach this type of problem. Be very careful about this type of problem because the angles are given differently. So the values will change accordingly, correct? Now, sixth problem. In triangle ABC, right angled at B, again right angled at B, if AB is 5 centimeter, so length of AB is 5 centimeter, this time it is given the specific length, not the ratio. And BC plus AC is equals to 25 centimeter. Oh, this one is a little bit tricky. Why? Because you will get confused how to approach this problem now. The length that is given to us is BC plus AC. Not of BC, not of AC, but their sum. What to do now? Okay, do one thing. Let's consider the length of AC to be x. Correct? Then what is the length of BC? AC minus, 25 minus AC, correct? From this equation, BC would be 25 minus AC. AC we are considering as x. So the length of BC will become 25 minus x. Correct? But still, the problem is not solved because now we are having the length of the sides in terms of algebraic expression. What to do now? Apply the Pythagoras theorem. Now only. So, hypotenuse square is equals to p square plus b square. Hypotenuse is x. So, x square is equals to any side you can consider as p. So, I am going with 5. 5 square. So, base will become 25 minus x whole square. X square as it is 5 square 25. Here I can apply the identity a minus b whole square. So, a square means 25 square 625 plus b square means x square and minus 2ab means 2 into 25 50x. Now look at this, x square and x square we can cancel them, and this minus 50x I will bring to left side, so will become positive term 50x. 25 plus 625 650. So x will be 650 divided by 50. 0 0 cancel, 65 by 5 13. Now I know the value of x 13. Then what is the value of 25 minus x? 25 minus 13 12. Now we know all the side lengths, correct? Not a problem anymore. We need to find what? Values of sine A. So let me erase this. So now the problem is very easy. So the only difficulty here is that the actual values are not given, but instead we need to apply the concept of algebraic expressions here to find the values of each side. Sine A, it means we are referring to this angle. Sine A is perpendicular by hypotenuse. perpendicular 12, hypotenuse 13. Then we need to find cos A. Cos A, we are referring to the same angle B by H, base, that is AB 5 centimeter, by hypotenuse again 30. Now we need to find cosecant C. So it means we are referring to this angle now, cosecant. Cosecant theta or C would always be equals to 1 by sin C. It means reciprocal of sin C. Sin is perpendicular by hypotenuse. 1 by sin C would become hypotenuse by perpendicular. So for cos C, hypotenuse is same 13 by perpendicular. Which side is perpendicular when we are referring to angle C? AB. So it will become 13 by 5. Correct? Then secant C. Secant C is nothing but reciprocal of cosecant 1 by cos C. Cos is B by H, base by hypotenuse. 1 by cos C would be H by B, hypotenuse by base. So for secant C, when we are referring to angle C, which side is hypotenuse? Same side 30, and base would be this 12. So these are the answers. This is how you can approach this type of problem. Understood? So yeah, these are the major type of problems that you can expect from trigonometric ratios only. So in this session, we understood the introduction part, introduction to trigonometry. Then we understood trigonometric ratios, which ratio, how to find them, how to memorize them. Remember the memory trick. Some people have curly brown hair till painted black, correct? That you can apply, and different type of problems we have seen, correct? So this is how you can approach. In the next session, what can you expect? I will tell you how to create this table. You may be familiar with this, correct? This is very useful because these are the angles that we are dealing with in 10th class. 0, 30, 45, 60 and 90. How to find the values of specific angles. So sin 30, sin 45, sin 90, cos, cosecant, how to find these values, I will tell you. How to create this table easily, I will tell you a trick also in the next session. So majorly we are going to discuss trigonometric ratios of some specific angles. So there are some specific angles that you are going to use in 10th class. What are the values of the trigonometric ratios for those angles? We are going to discuss this part. Then trigonometric identities. Identities we have already we are already familiar with identities, no? Like a plus b whole square, a minus b whole square, a square minus b square. These are algebraic identities. In this session, we are going to discuss trigonometric identities. Then problems, of course, the most important part. How to solve problems based on this chapter, how to approach them, how to solve them, prove them, correct? And then we are going to summarize the chapter. That's it. So this is very easy chapter. Please don't judge the chapter because of name or because this chapter has been included for the first time in your entire life. So don't judge this chapter because of that. This is very easy chapter. You can easily score in this chapter. I will tell you how. Now, first thing that in the previous session, we discussed this table, correct? This table do summarize what are trigonometric ratios, how to find them, actually what are their values if a triangle is given. So 6 trigonometric ratios are sine, cos, tan, cosecant, secant and cot, correct? Sine theta is perpendicular by hypotenuse, but again I'm telling you, perpendicular, hypotenuse is fixed side, the side opposite to the 90-degree angle. But what about perpendicular? Perpendicular is that side which is side opposite to the angle which is being referred. Suppose if we are talking about triangle ABC, let me use my pen. So if we are talking about triangle ABC, so this is angle 90 degree now. Side opposite to this angle is the hypotenuse. Okay, Fine. Now, depending on which angle we are referring to, we can have different perpendicular, different base, correct? Suppose we are referring to angle C. Then side adjacent is the base of this triangle. So this is the adjacent side BC. So this is the base. Then side opposite is the perpendicular. So this is perpendicular. Now suppose if we are referring to angle A, then side adjacent is AB. So this is base when we are referring to angle A, and BC will become perpendicular when we are talking about angle A. So depending on which angle we are referring to, we can have different perpendicular, different base. But you can understand it like this: side adjacent will always be the base, side opposite will always be the perpendicular. Okay. Now, cos. Cos is nothing but the complementary of sine. So full name is cosine, but in short you can write COS, cos. Cos theta is base by hypotenuse. This is the basic formula. Tan, this is short form. Full is tangent. Tangent is perpendicular by base. Then cosecant is nothing but the reciprocal of sine. As I told you in the last session, that there are three primary trigonometric ratios. The other three are nothing but the reciprocals of the primary ratios. So cosecant is reciprocal of sine, 1 by sine. So if sine theta is perpendicular by hypotenuse, then 1 by sine would be what? Hypotenuse by perpendicular. So cosecant theta is hypotenuse by perpendicular. Secant is nothing but the reciprocal of cos. So 1 by cos. Cos theta is base by hypotenuse. 1 by cos would be hypotenuse by base. Cot is reciprocal of tangent or tan. So 1 by tan. Tangent is perpendicular by base. So 1 by tangent will become base by perpendicular. So this we understood. This we can easily remember. There's a memory trick also, right? I told you in the last session, some people have curly black hairs till painted black, correct? This memory trick you can use to remember these ratios, correct? Now, standard angles. In 9th class, mostly we are dealing with these angles only. One angle is fixed. In the triangle that is given to us, suppose one angle is having fixed value, that is 90 degree, because we are dealing with right angle triangles, correct? The other angles, both the values are complementary to each other, correct? Complementary means their sum is always 90 degrees. Now, mostly you are going to deal with 0 degrees. If suppose one angle is 0, then other one is 90 degree. So it means we need to deal with 90 also. If one angle is 30 degree, then other angle is 60 degrees, correct? So we are dealing with 30, 60. And if one angle is 45, then the other one is also 45. So it means we need to deal with 45 degrees also. So these 5 angles are what we are gonna deal with in 10th class. In this chapter also, but mostly you are gonna use these values in the next chapter, where we will be finding heights and distances depending on different scenarios, correct? So this is not difficult. Now, what are their values? I will tell you a trick to create a table with the help of which you can easily remember the values. The table will look something like this. Here in this table, I will create 6 columns and 8 rows. In this table, as you can see, all the common angles are written here: 0, 30, 45, 60 and 90. And all the 6 trigonometric ratios are written here: sine, cos, tan, cosecant, secant, cot. Correct? Now, how to fill up the values? What is sine 0 degree? What is the value? It should be written here. Sine 30 degree should be written here. Sine 45 here. But how to create this? What is the trick behind this? If you are not able to remember this completely, then I'm gonna tell you a trick now. You remember the counting, no? Counting numbers, whole number starts from where? 0. So I will do one thing. I will write 0 here, 1 here, 2, 3 and 4. You can do that. 0, 1, 2, 3, 4. You need to write this first. Then you will divide each value by 4. Each value by 4. Easy. Correct? Now you are going to put under root. Now find this value. 0 by 4. 0 divided by any number is always 0. Under root 0 is also 0. So this will be 0. So sine 0 degree is 0. Then sine 30 degree is under root 1 by 4. Under root 1, 1. Under root 4, 2. So under root 1 by 4 will become 1 by 2. Under root 2 by 4. 2 and 4 are divisible by 2. So it will become under root 1 by 2. Correct? Under root 1 by 2 doesn't have any specific whole number value. So we will go with under root 1 by 2 or 1 by root 2 because under root 1 is 1 only. So it will become 1 by root 2. Under root 3 by 4. Under root 3, okay, we can leave it as it is, under root 3, and under root 4 is 2. So this value will become root 3 by 2. 4 by 4 is 1, under root 1 is 1 again. So this will become 1. Now you know all the values of sine. Sine 0 degree, sine 30, sine 45, sine 60, sine 90. Correct? What about others? Okay, do one thing. All the values that you have here now, you're gonna write them in opposite way. Last value you should write first here in cos. So what is the last value? 1. So I will write 1 here. Second last value I will write here, root 3 by 2. Then third last value, 1 by root 2. Then this value will appear here, 1 by 2. This value will be the last value of cos. Now we have all the values of cos theta. Correct? So this is looking a little bit clumsy, the sign values. So let me erase and let me put the single value only. Now, because you know the trick now, na? First, you are gonna write 0, 1, 2, 3, 4. Then you will divide each value by 4. Then you will find the under root. What is tan theta? Tan theta is perpendicular by base, correct? And last time I told you that tan theta can be found using one more method, and that is sine theta by cos theta. So we are gonna do this only. We are gonna divide these values with each other. Sine theta by cos theta will be the value of tan theta. 0 divided by any number, 0. So tan 0 degrees is 0. 1 by 2 divided by root 3 by 2. 2 and 2 are gonna cancel each other. We are left with now 1 by root 3. 1 by root 2 divided by 1 by root 2. 1. Same values when they are divisible is gonna give us 1. Root 3 by 2 divided by 1 by 2. 2 and 2 cancel. We will be left with root 3. 1 by 0. 1 by 0 is a fraction, correct? Fraction usually tells us that what portion we are considering out of how many. The number written in numerator is telling us how many portion we are considering. The number in denominator usually tells us out of how many, the total number of portions. Here the fraction will become 1 by 0. So it means we are considering one part out of total 0 parts. This is not possible. So this situation as of now is not defined in mathematics. So the value will become 1 by 0 will become not defined. Okay. Now you are gonna do one thing. Either you can find for cosecant theta, it would be reciprocal of sine theta. So find the values of reciprocal of sine theta. So 1 by 0, again not defined situation. So I will write ND in short. Then 1 by 1 by 2. So it will become 2. 1 by 1 by root 2. It will become root 2. 1 by root 3 by 2. It will become 2 by root 3. And 1 by 1, 1. Secant theta is reciprocal of cos theta. So 1 by 1, 1. 1 by root 3 by 2, 2 by root 3. 1 by 1 by root 2, root 2. 1 by 1 by 2, 2. And 1 by 0, not defined. Now, if you realize that this row and this row, the numbers are written opposite, correct? Whatever value is first here, it is the last value of this row. Whatever is the value here in the end, it is the first value of this row, correct? So they are written in the opposite order. Cot theta can be found using 1 by 10. So again, 1 by 0, not defined. 1 by root 3, root 3. 1 by 1, 1. 1 by root 3 is 1 by root 3. And 1 by not defined is 0. It will be 0. Now, look at these two, tangent and cot. Are they written in opposite order? Yes, they are. So it means there are 2-3 ways by which you can create this table easily. But you are not remembering anything, correct? You are just only performing basic operations and still you are getting the same table. So if you are not liking my handwriting, let me show you the computer written table. So this is the table that we are talking about. Sin theta is when it is 0, it will give you sin 0 value. Sin theta when it is 30 degree, when theta is 30 degree, will give you 1 by 2. Sin 45, 1 by root 2. Sin 60, root 3 by 2. Sin 91. And so on for any other trigonometric ratio. You can easily find the value. So if you are going in the final exam, do one thing. Create this table first. Because I am sure that there will be a problem from some applications of trigonometry in 5 marks, correct? So you want to score 5 marks and you don't want to waste time. So create this table anywhere in your rough sheet, correct? Then when you are solving that problem, then you can easily use this table. This is very usable. Even in 1 mark or 2 mark, they will give you some problem related to values, na? Then also it is usable. So if you can score 5 to 7 marks from this table itself, so first create the table in the rough sheet, okay? So this is how you can create 0, 1, 2, 3, 4, divide each value by 4, then take the under root, that will be the sine value, correct? Then write the numbers in the opposite order for cos, divide them for tangent, then 1 by sine will be cosecant, 1 by cos will be secant, and cot would be 1 by 10. Easy. Now, this is how you can create table. Done. Now, identity. Identity, as I told you, is a very big part of this chapter, because using identities, we need to solve some problems. We are gonna prove some things. So what are trigonometric identities? In case of algebraic identities, we know that a plus sorry, a plus b whole square, a minus b whole square, like that, correct? And there are multiple algebraic identities, correct, that you know of. In case of trigonometry, trigonometric identity is something which is true for all values, no? Here we are dealing with what? Either side ratios or angles, correct? So an identity, and trigonometric identity is an equation which is true for all the values of the angle for which both sides are defined. So for whatever angle we are defining it, it is always be true. That's why it is known as identity. Now, basic identities, basic trigonometric identities are sine square theta plus cos square theta is equals to 1. 1 plus tan square theta is equals to secant square theta. 1 plus cot square theta is equal to cosecant square theta. Again, if you are finding it difficult to remember this, then how to remember this so that you can use it. Let me tell you one trick for this also. So the trick is, you know Pythagoras theorem. What is Pythagoras theorem? That in any right angle triangle, if in any right angle triangle, square of the hypotenuse will always be equals to sum of the squares of other two sides. Correct? So using the Pythagoras theorem, we can easily find these identities. Let me show you. So given a right angle triangle ABC, right angled at B. So now here you can see sine square theta plus cos square theta is equals to 1. Suppose theta is this angle, because we need to consider one angle, na? Then only we can define which side is perpendicular, which side is base. You can also define this as theta, no problem. But the base and perpendicular will change accordingly, correct? Now, if angle C is theta, so of course AC is the hypotenuse, because this is the side opposite. I will refer them using the initials. H for hypotenuse, then side opposite to theta will be the perpendicular. So I will write P here for perpendicular, and the side adjacent is the base. So B for base. Okay. Now, according to Pythagoras theorem, hypotenuse square will always be equals to perpendicular square plus base square. Hypotenuse square means AC. AC square is equals to perpendicular square means AB square plus base square means BC square. Do one thing, divide whole equation by AC square, same value, because I need sine square theta, cos square theta, correct? Perpendicular is AB square, base is BC square. What is sine theta? Perpendicular by base, perpendicular by hypotenuse, correct? What is cos theta? Base by hypotenuse. So here, if somehow I am able to create perpendicular by hypotenuse and base by hypotenuse, then I will get what? Sine theta and cos theta. And they are squared values, so it will become sine square theta, cos square theta, correct? Also, it will eliminate this AC square also, because I need to divide these two by hypotenuse and I cannot change the overall value of the equation. So I need to divide both the sides with the same value, correct? So dividing both sides by AC square. By AC square, we are going to divide both sides. So it will become what? AC square by AC square is equals to AB square by AC square plus BC square by AC square. These two are going to cancel each other. So what are we left with here? 1 is equals to AB square by AC square. We can take this square common, no? So it will become AB by AC whole square. What is AB by AC? AB is the perpendicular, AC is the hypotenuse. It is basically sine theta. Sine theta, but square, so sine square theta. BC by AC is what? BC is the side adjacent or base and AC is the hypotenuse again. So this will be cos theta, but squared value, so cos square theta. As you can see now, this is our first identity. Sine square theta plus cos square theta is equals to 1, correct? So this is how you can find it. Even you can remember this easily now, because now you know na the relation from where it is coming. So that's why it is easily rememberable. Second identity. Second identity is 1 plus tan square theta is equals to secant square theta. Correct? Now, we need what? First thing that I can see here, that on right hand side, it is secant square theta, the only value. Secant theta is what? 1 by cos theta. Correct? Cos theta is base by hypotenuse. So secant theta is what? Hypotenuse by base, correct? So somehow I need to create hypotenuse by base here. Suppose if this is the angle, that is theta, then this is hypotenuse, this is perpendicular, this is base. So on the right side, I will be having AC by BC somehow, correct? So apply the Pythagoras theorem again. So P square plus B square is equals to H square. Perpendicular square plus base square is equals to hypotenuse square. Perpendicular here is what? AB. So AB square plus B square means BC square. Hypotenuse means AC square. I need on the right side secant theta, or basically hypotenuse by base. So I should be dividing whole equation by BC. That will solve two problems. Here I will be getting AB by BC. AB by BC is perpendicular by base, tan theta. I need tan theta, correct? And on the right side, I will be having hypotenuse by base. That will give me secant theta, and also BC by BC is going to give us, correct? So divide whole equation or both sides by BC square. If you do that, it will become AB square by BC square plus BC square by BC square is equals to AC square by BC square. They are going to cancel each other. Here, as we can see, AB square by BC square, square we can take common, it will become AB by BC. AB by BC is perpendicular by base. Perpendicular by base is tan theta, but squared value, so it will become tan square theta plus. This is 1 only, so we cannot do anything. On the right, AC by BC, square we are taking as common. So AC by BC is what? AC is hypotenuse, BC is base. Hypotenuse by base is secant, but squared value, so it will become secant square theta. Correct? Again, you can see the identity, same identity. So we are only applying the Pythagoras theorem, and we are dividing the whole equation by one-sided, and that way you will get your identities. Now third one, now you must be thinking that this is easy, no? Correct? So again, this is theta, so hypotenuse, perpendicular and base. We need what? Cot theta. Cot theta is reciprocal of tan theta. Tan theta is what? Perpendicular by base. So cot theta would be 1 by perpendicular by base. So basically base by perpendicular. So it means I need base by perpendicular, BC by AB. Correct? So first I will write the Pythagoras theorem. P square plus B square is equals to H square. Now P square means AB square. B square means BC square, AC square. I need cot theta means base by perpendicular, BC square by AB square. So it means I need to divide the whole equation by AB square, because I need 1 also. So AB by AB will give me 1. BC by AB will give me cot. And what about AC by AB? AC is perpendicular, hypotenuse, and AB is perpendicular. So cosecant theta is basically 1 by sin theta. Sin theta is perpendicular by hypotenuse. So cosecant theta is hypotenuse by perpendicular. So that will also follow, correct? So divide both sides by AB square. So it will become AB square by AB square plus BC square by AB square is equals to AC square by AB square. These two are going to cancel each other. So it will give us 1 plus BC by AB when square is taken common. So BC by AB, BC by AB is base by perpendicular, that is cot square. Cot theta but squared value, so cot square theta is equals to AC by AB, hypotenuse by perpendicular. Hypotenuse by perpendicular is cosecant theta, but squared value, so cosecant square theta. Correct? So this is how you can find the identities, or you can derive the identities. So basically, what are we doing here? We are utilizing the same Pythagoras theorem, considering one angle to be our theta. Depending on that theta, we can realize which side is hypotenuse, perpendicular, and base. Then we are dividing the whole equation by one side at a time. That way, you can easily find all three identities that you are gonna use in this class. Correct? So now you understood the concept, how to find the identities. So the first problem is, prove that secant A into 1 minus sine A into secant A plus tan A is equals to 1. Now, this type of problems are the major headache for you in this chapter, correct? And you are afraid that how to approach such problems, correct? Let me tell you frankly, most of the time, the problem that you are going to deal with can be solved by converting those un, uh, those unrelated trigonometric ratios which are not sine and cos to sine and cos. If you can see different trigonometric ratios in the problem, so try to do one thing, convert all of them in terms of sine and cos. All of them can be converted, correct? Why? Sine and cos are sine and cos, so no need to convert them. But suppose if you are having tangent, then what can you do? You can apply this relationship. Tangent A or tangent theta will always be equals to sine theta by cos theta. So again, you are seeing sine and cos. Suppose cosecant theta is there, so you can convert it to 1 by sine theta, correct? If secant theta is there, then you can convert it to 1 by cos theta, correct? And if cot theta is there, then we know that cot theta is 1 by tangent theta. Tangent theta is sine theta by cos theta. So cot theta will become cos theta by sine theta. So any trigonometric ratio can be converted in the form of sine theta and cos theta. Okay. Now, so in this problem also, we are gonna follow the same approach. First thing first, we are gonna consider the left side only, because in the right side it is only one. Na? If somehow I will be able to convert this value on the left side equals to 1, then we can easily say that RHS equals to LHS true, correct? So let's do one thing. LHS. Consider only LHS. What is LHS? Secant A into 1 minus sine A into secant A plus tan A. We are going to convert every trigonometric ratio in terms of sine and cos. Okay. Secant A is nothing but the reciprocal of cos. So it will become 1 by cos A. 1 minus sine A is in terms of sine A only. So it will remain as it is, 1 minus sine A. Secant A again. So it will become 1 by cos A plus tangent A is sine A by cos A. Now, we can take cos A common here, correct? And this we can club. So it will look like 1 minus sine A divided by cos A. Here, inside the bracket, we can take cos A common. So the numerator will become 1 plus sine A. Now they are in multiplication, both the values. So if that is the case, so we can multiply the numerators and we can multiply the denominators. So 1 minus sine A into 1 plus sine A. A minus B into A plus B. Remember the identity? So it will become what? A square minus B square. So this will become A square is 1 square, 1 square, 1. Minus B square is sine square A, correct? And in denominator, what do we have? Cos A into cos A. So cos square A. Now we are here now. So let me divide the whole portion in half. So we are going to continue from this portion. We know the identity. Which identity? Sine square A plus cos square A is always equals to 1, correct? So let me use this space. Sine square A plus cos square A is always 1. If I transpose this sine square A to right side, so equation will become cos square A is equals to 1 minus sine square A, right? Here I can see 1 minus sine square A. So in place of 1 minus sine square A, I can directly write cos square A, correct? So here 1 minus sine square A will become cos square A, and in denominator it is already cos square A. They are gonna cancel each other. So what are we left with now? 1. So this is your LHS now. This is your RHS. So LHS is equals to RHS now. Hence prove. This is how you can prove this problem. As I told you, most of the time in 80% of the problems, you can do one thing. You can convert every other non-sine cos value to sine cos. You know the relation, correct? That you can use here. Then you are performing basic operations only. LCM you are taking, adding, subtracting, multiplying, dividing. This only you are doing. Then at some point you may be using trigonometric identities also. That way you can easily prove such problems, correct? Easy approach. Now let's see what you have learned so far. So here in this problem, second problem, we need to prove that cot A minus cos A divided by cot A plus cos A is equals to cosecant A minus 1 divided by cosecant A plus 1. So now how to approach this one? Anyone? Again, we are gonna take the LHS, correct? As you guys are saying, we should consider LHS, okay? If somehow we can convert this value back to this one, our work is done, correct? So LHS is cot A minus cos A divided by cot A plus cos A. Now, the same approach we are going to apply here, that we are going to convert every other non-sine cos value to sine cos value. Okay. What is cot A in terms of sine and cos? Cos by sine, because cot A is the reciprocal of tan. Tan is sine by cos, correct? So cot A will become cos A by sine A. Okay. So this will become cos A divided by sine A minus cos A upon cos A upon sine A plus cos A. Now what? As you can see in the right side of the given problem, we need minus 1 and plus 1. Is it possible somehow? Yes, it is. Suppose if I take cos A common from the numerator and cos A from the denominator, then in the bracket I will be having minus 1 here, minus plus 1 here, correct? So, okay. Take cos A common in numerator. Then inside bracket, what are you having now? 1 minus sine A minus 1 upon cos A from here also. Then you must be having 1 minus 1 by sine A plus 1. Cos A and cos A are going to cancel each other. We need cosecant A minus 1 and cosecant A plus 1. Do we have any relationship between sine and cos? Cosecant, sorry. Yes, we do have a relation. That is, cosecant A is always equals to 1 by sine A, correct? Now, 1 by sine A is cosecant A, so it will become cosecant A minus 1 divided by 1 by sine A here also, so cosecant A plus 1. This is what we need to prove, correct? Now, as you can see, LHS is equals to RHS, hence proved. Easy. We are doing the same thing, converting every other known sine cos value to sine cos, performing the basic operations, remembering the basic relationship, and then getting the final value, correct? Now, third part. Here, the problem is cos theta by 1 minus tan theta plus sin theta by 1 minus cot theta. We need to prove this equals to cos theta plus sin theta. Okay. Same thing we are gonna do here. We are gonna convert every other known sine cos value to sine cos and considering only LHS. LHS. Cos theta by 1 minus tan theta plus sin theta by 1 minus cot theta. Now, tan theta and cot theta are two values which we need to convert, correct? Because sine cos are sine cos only. Cos theta by 1 minus tan theta is sin theta by cos theta. Sin theta by cos theta plus sin theta as it is divided by 1 minus cot theta is reciprocal of tan theta, so it will become cos theta by sin theta. Now, we can take the reciprocal here, correct? Then after taking the reciprocal, yes, doing good. Now, after taking the reciprocal, it will become not reciprocal, the LCM, the denominator part will become 1 and there is no denominator part here, so the LCM would be cos theta only. So the denominator part will become cos theta minus sin theta by cos theta plus sin theta by, this will become sin theta minus cos theta by sin theta, right? Now, this can be taken in the numerator part. Same here, we can take this into the numerator part. So, the equation will become cos theta into cos theta is gonna give us cos square theta divided by cos theta minus sin theta as it is. Plus sin theta into sin theta, sin square theta divided by sin theta minus cos theta. Now, look at this. Now we cannot proceed further because denominators are different, numerators are different. We cannot take anything common. But how about if I take minus sign common from the denominator part of the second term? Then it will become what? Cos theta minus sin theta, same as this one, correct? Okay, let's go with this. Cos square theta by cos theta minus sin theta. If I'm taking minus sign common, so I need to put that negative sign here. So it will become minus sin square theta by cos theta minus sin theta now. Correct? Now the denominators are equal. So we can perform the operations on numerators, correct? Directly. So it will become cos square theta minus sin square theta divided by cos theta minus sin theta. Now look at this. If we were if we were having cos square theta plus sin square theta, then we can directly write this one as 1, correct? But that is not possible because the operation in between is negative, minus. So, and also we need cos theta plus sin theta. So it means we need to somehow eliminate the denominator. If I'm looking at this value, cos square theta minus sin square theta, it is reminding me of a square minus b square. So that identity I can apply here. According to that identity, cos square theta minus sin square theta will become cos theta minus sin theta, cos theta minus sin theta into cos theta plus sin theta divided by cos theta minus sin theta. Now look at this. All these terms are in multiplication and division only, no? So we can eliminate these two because they are equal. What are we left with now? Cos theta plus sin theta. The same thing that we need to prove. So now LHS is equals to RHS, hence proved again. Again, we are applying the same concept here also, converting the values in terms of sin and cos, then performing the basic operation. Sometimes you may apply some other than normal logic, like here we are applying the identity, correct? Then we are cancelling the common part, correct? That you need to do, but you will realize this easily because here we need to eliminate the denominator, correct? Because there is no denominator part in the RHS side. So how to remove it? Open the identity. That way we can remove. Now fourth one, prove that secant theta plus tan theta minus 1 divided by tan theta minus secant theta plus 1 is equals to cos theta by 1 minus sin theta. Now this one is a little different initially. Why? If I directly convert them, that will not solve my purpose. If I directly convert them in terms of sin cos, that will not solve my purpose. Although I need to convert them at some stage, correct? Because I need cos and sin only. But initially, we need to apply a different logic. What? First, LHS. So, secant theta plus tan theta minus 1 divided by tan theta minus secant theta plus 1. Do we know one trigonometric identity in terms of secant and tangent theta? That is 1 plus tan square theta is equals to secant square theta. If I transpose tan square theta to right side, the identity will become what? 1 equals to secant square theta minus tan square theta, correct? So in place of this one, I will put that identity here. So why I am doing this? Because I need to get uh, I need to get rid of this tan theta minus secant theta plus 1, this whole thing. I just only want 1 minus sin theta, and in numerator only cos theta is there. So I need to eliminate these two things, correct? So first I will convert this one to secant theta plus tan theta minus secant square theta minus tan square theta. So this identity I will apply here. Minus sign will remain outside, okay? This we not touch. Again, we can apply a square minus b square here, correct? So secant theta plus tan theta. You can put this in bracket minus here. I will open the close bracket now. Sorry, square bracket now. And inside a square minus b square, a plus b into a minus b. So secant theta plus tan theta and secant theta minus tan theta divided by tan theta minus secant theta plus 1. Correct? Now look at these two terms, this one and this whole term. Out of these two terms, can we take anything common? Yes, we can. What is that? Secant theta plus tan theta. So if we are taking secant theta plus tan theta common, then we are gonna left with some part. So first write the common that you are taking. Secant theta plus tan theta. Inside, out of this term, what are you left with? 1. Only 1 minus. And from this term, what are you left with? Secant theta minus tan theta. Now suppose secant theta minus tan theta, what you are left with? If you are opening the bracket, so it will become minus secant theta and minus minus plus tan theta. So 1 minus secant theta plus tan theta is what you are left with inside. And in denominator, we are left with tan theta minus secant theta plus 1. Tan theta minus secant theta plus 1. If you look at these terms again, this whole term and this whole term, they are equal, aren't they? Yes. So we can cancel them. Yes, we can. After cancellation, what are we left with? Secant theta plus tan theta. Now we need the whole value in terms of cos and sine, correct? So are we having any relationship between secant theta and tangent theta? Yes, yes. What you are saying is also true. Now, is there any relationship between secant theta and secant theta and tangent theta in terms of sine and cos? Yes. Secant theta is 1 by cos theta. Tan theta is sine theta by cos theta. Still, we can take cos theta common, but the main problem will become that in numerator it is 1 plus sine theta, in denominator it is cos theta. But I need cos theta in numerator and 1 minus sine theta in denominator. Okay, what to do now? See, if somehow I will convert this 1 plus sine theta into cos theta and cos theta into 1 minus sine theta, then my problem is solved. But how to do this? I can do one thing. I can multiply the whole expression with 1 minus sine theta. Why would I do that? If I multiply whole expression with 1 minus sine theta and divide with the same value also, then in numerator I will get 1 square or 1 minus sine square theta. That is equals to cos square theta, correct? Not exactly equals to cos theta, but closer. And we will see what changes we can see in the denominator also. So multiply with 1 minus sine theta by 1 minus sine theta. A plus b into a minus b. A square minus b square or 1 minus sine square theta divided by cos theta into 1 minus sine theta. Look at this. This is cos square theta. 1 minus sine square theta is cos square theta divided by cos theta into 1 minus sine theta. Cos theta and square are cancelled. Now what are you left with? Cos theta divided by 1 minus sin theta, same RHS value. So from here we can simply say that LHS is equals to RHS. The only different thing that we are doing here is we are converting this value to secant square theta minus tan square theta. And after that we are taking common, cancelling the common parts, then we are again converting values back to sine and cos, correct? Now this one, prove that under root of 1 plus sine theta by 1 minus sine theta plus under root of 1 minus sine theta by 1 plus sine theta is equals to 2 secant theta. This problem did appeared in the exams before, in the board exams, but this is very easy. This is easier than the previous one. How? First thing, as you can see, this is having under root value, so this might confuse you, correct? No, please don't. Uh, please don't feel pressured now. Again, same thing, LHS. LHS is under root of 1 plus sine theta by 1 minus sine theta plus under root of 1 minus sine theta by 1 plus sine theta. This is LHS. So under root we can separate, correct? This basically means that under root 1 minus sine theta divided by under root 1 minus sine. Oh, this is 1 plus sine theta, no? Yeah. This basically means that under root 1 plus sine theta divided by under root 1 minus sine theta. Now, this means that under root 1 minus sine theta divided by under root 1 plus sine theta. So we can separate 1 plus sine theta divided by under root 1 minus sine theta plus under root 1 minus sine theta divided by under root 1 plus sine theta. Take LCM. What will happen? If we are taking LCM, then this term and this term we need to multiply. So it will become squared value, square and square root are gonna cancel each other. Same goes for these two terms. They are gonna multiply each other. Then that way it will become squared value, square and square root are gonna cancel each other. Correct? So take the LCM. LCM would be 1 minus sine theta in under root multiply under root 1 plus sine theta, and this value will become under root 1 minus sine theta into under root 1 minus sine theta squared value, so under root 1 plus sine theta whole square plus this will become under root 1 minus sine theta whole square. Square and square root are gonna cancel each other, correct? So what are we left with now in the numerator? 1 plus sine theta plus 1 minus sine theta divided by this value minus sine theta plus under root, this is 1 plus sine theta, correct? Sine theta and sine theta are gonna cancel each other, so this will become 1 plus 1 2. So here I will use this space. 1 plus 1 2. In denominator what are we having? Under root we can take, why I'm writing plus here, there's no plus sign here. Under root 1 minus sine theta into under root 1 plus sine theta, when they are multiplied it will become under root a plus b into a minus b, so it means under root a square minus b square. So this value will become 1 square 1 minus sine square theta. Now 1 minus sine square theta is cos theta. So this will become 2 by under root cos square theta. Under root and square are gonna cancel each other. So this is 2 by cos theta. But cos theta and secant theta are reciprocal of each other. So 1 by cos theta I can write as secant theta. So this will become 2 into secant theta. This is how you can approach this problem. So this is easier than the previous one, no? So what are we doing? We are just taking the LCM first. Then we are seeing that it will become squared value, square and root are going to cancel each other. Here we can see that under root, after taking under root common, this will become an identity a plus b into a minus b, simply a square minus b square. But here in this case, a square minus b square is 1 minus sine square theta. That is one more trigonometric identity, that is sine square theta plus cos square theta is equals to 1. So from here we can replace this value with cos square theta. Again square root are going to cancel each other and 1 by cos is secant theta. So the final answer will become 2 secant theta. Understood? Understood everyone? Please let me know in the chat box. Understood? Correct? Now this problem, cosecant theta into cosecant theta divided by cosecant theta minus 1 plus cosecant theta divided by cosecant theta plus 1, we need to prove this one to be equals to 2 secant square theta. Similar type of problem, but we are going to deal with cosecant theta now. So what are we going to do here? First thing, we are going to take the LCM again. That way we are going to multiply this value with whole, this value and this value with this value whole, and when they are being multiplied with themselves, it will again give us the identity a square minus b square, correct? So LHS. So I'm just directly taking the LCM. First you need to write the LHS also, but I'm directly writing the LCM. I am directly taking the LCM. So it will become in denominator cosecant theta minus 1 into cosecant theta plus 1, and here it will become cosecant theta into cosecant theta plus 1 plus cosecant theta into cosecant theta minus 1. Multiply them. Cosecant into cosecant, cosecant square theta plus cosecant theta. Here again cosecant into cosecant, cosecant into minus 1 minus cosecant theta divided by a minus b into a plus b, a square minus b square. So cosecant square theta minus 1 square is 1 plus cosecant theta minus cosecant theta are going to cancel each other, and cosecant square theta plus cosecant square theta will become 2 cosecant square theta. Now do you remember the identity that cosecant square theta is equals to what? Cosecant theta, cosecant square theta is having identity 1 plus cot square theta, correct? So we are going to put that value here, minus 1. They are going to cancel each other. So what are we left with? Okay, let me use this place. 2 cosecant square theta divided by cot square theta. We need to convert this into secant square theta. So if you know the relationship, you can directly go with secant square theta relationship. But if you are not sure, then you can convert these values to sine or cos in terms of sine and cos. So look at this. 2 cosecant square theta is having a relationship with sine, so it will become 1 by sine square theta. So 2 into 1 by sine square theta divided by cot square theta is cos theta by sine theta. So squared value cot square theta by sine square theta. Cos square theta divided by sine square theta. Now look at this. Sine square and sine square theta are going to cancel each other. What are we left with? 2 divided by cos square theta. 1 by cos theta is secant theta. 1 by cos square theta is secant square theta. So this is going to give us 2 into secant square theta. LHS is equals to RHS. Hence proved. This is how you can approach this problem. So there's nothing that we are doing extraordinary here. We are just taking the LCM, opening the brackets, subtracting what is common, then adding, then applying the identity here. So the main step is this one, that you need to realize that cosecant square theta is 1 plus cot square theta. 1 and 1 are going to cancel each other, converting these values back to sine and cos. Also, although you can directly go with other values also, that you can that can help you in converting back into secant square theta, but if you are not sure, go with sine cos. They are easier to remember. Then after looking at this, we are getting 2 divided by cos square theta. 1 by cos square theta is secant square theta. So we are getting LHS and RHS as equal now. So this is how you can approach this problem. Let's solve one. Here in this problem, we need to convert sine A by 1 plus cos A plus 1 plus cos A by 1 plus cos A by sine A to 2 cosecant A. Same approach we are going to apply here. Cosecant A we know is having a relationship with sine, correct? That is 1 by sine. So here all the values are in terms of sine and cos only. So directly find the LCM then. Okay, LHS. Taking LCM is, it will become what? Sine into, okay, let me take the LCM. 1 plus cos A into sine. Correct? Sine A into sine A, sine square A, plus 1 plus cos A into 1 plus cos A, 1 plus cos A whole square. Okay? Please don't get confused yourself. 1 plus cos A into 1 plus cos A would be 1 plus cos A whole square. So it will be 1 plus cos A whole square. Now, open the identity. Sine square A plus A square, because this is A plus B whole square. So A square means 1 square, 1, plus B square means cos square A, plus 2AB means 2 cos A, divided by, I will not touch these, 1 plus cos A into sine A. Now, sine square A plus cos square A, 1, identity. So this is going to give us 1. This one as it is, plus 1, plus 2 cos A, divided by 1 plus cos A into sine A. As you can see here, 1 plus 1 is 2. So let me use this space. And plus 2 cos A as it is. So this will become 2 plus 2 cos A divided by 1 plus cos A into sine A. If I take 2 common in numerator, what will I get? 1 plus cos A. In denominator also we are having 1 plus cos A. So that's why I didn't multiply them, so that I can cancel them. Correct? So 2 we are taking common, 1 plus cos A is what we are left with. So 1 plus cos A in denominator into sine A. We are going to cancel them. Also, we know the relationship. Cosecant theta is always equals to 1 by sine theta. Here we are having 1 by sine A, so it will become cosecant A. So 2 into cosecant. This is your LHS, this is your RHS, they are equal. Hence, prove. This is how you can prove this one. So we have seen different approaches, no? But most of the time, what are we doing? Either we are converting values back to sine and cos, correct? Either we are applying the trigonometric identities. You need to remember them. If you are not able to remember them, I already told you the trick how to find them, correct? That you can apply. Then basic operations only. So now we have seen different type of problems and we are done with this. So let's see what we have understood in this session. In this session, we understood the different trigonometric ratios of some specific angles like 0, 30 degree, 45, 60 and 90 degree, correct? How to create the table, I told you the trick. How, please utilize that trick. That way you can make sure that you will be getting at least 5 to 7 marks very easily, because that table is applicable in this chapter also, in the next chapter also, some applications of trigonometry. As we know, the name of the chapter is some applications of trigonometry. Why we are using some? Because in this standard 10th class we are going to talk about some applications only, because there are too many applications of trigonometry. Okay, now in this chapter I will again explain some things that are required from the previous chapter, so that's why prerequisite. And then heights and distances is the main part of this chapter, so we are going to deal with height and distances here. Then we are going to summarize the chapter after solving some problems. Okay, now prerequisite that I will be explaining what are different things related to trigonometry. So in 10th class, we are majorly dealing with right angle triangles when it comes to trigonometry. Right angle triangle means that one angle of that triangle is exactly 90 degrees. So now suppose ABC is a right angle triangle. So angle B is right angle, means the value of angle B is 90 degrees. So now this is 90-degree angle. Side opposite to angle that is 90 degree is always known as hypotenuse. So I'm gonna write H in short. Now, depending on which angle we are referring to, we can have different names for the other two sides. Like for example, suppose if I'm referring to angle C, this angle, then side adjacent to this angle C, there are two sides which are adjacent to angle C, that is AC, but already we are having a particular name for AC, that is hypotenuse, and then we are having BC. So the other side that is adjacent to angle C is also known as base. Then side opposite to angle C is known as perpendicular. So if we are referring to angle C, then this is the base and this is the perpendicular. But suppose if we are referring to angle A, then which side is base now? Because there are two sides which are adjacent to angle A. AC again, the hypotenuse, and AB. So if we are referring to angle A, then AB will become our base side and side opposite BC will become the perpendicular. Why this is necessary? Why we need to understand this? Because we are going to apply these things, hypotenuse, perpendicular, base, to find the value of different trigonometric ratios. So there are 6 trigonometric ratios: sine, cos, tan, cosecant, secant and cot. These 6 are somehow related to the sides, not the actual length but the ratio. Why ratio? Because we can enlarge or decrease the size of a triangle. If we are not changing the value of angle, then the ratio of the sides will remain the same. So that's why we are going to deal with the ratio, not the actual length. Now, sine value can be found using the formula perpendicular by hypotenuse. Whatever angle you are referring to, depending on that angle, you can see that perpendicular and base can be different, correct? So sine of that angle, suppose in this case angle C is theta. So sine theta in this triangle will be what? Perpendicular AB divided by hypotenuse AC. Whatever their length is, you can find their ratio, and that will be the value of sine theta. Cos theta would be base by hypotenuse. Then tan theta. One thing, when we are going to deal with heights and distances in this chapter, some applications of trigonometry, so majority of the time you are going to deal in terms of tan theta, because tan theta is what? Look at this tan theta. Tan theta is perpendicular by base. When we are dealing with height, so it means we are talking about the vertical distance, correct? When we are talking about the distance, we are talking about the horizontal distance. So perpendicular and base are the two things which usually represent the vertical and the horizontal distance between any two objects. So that's why you are going to deal with tan theta most of the times in most of the problems. Value of tan theta is perpendicular by base. Then cosecant theta is reciprocal of sine theta. So 1 by sine theta, or in terms of ratio, it will become hypotenuse by perpendicular. Secant theta is reciprocal of cos theta. So 1 by cos theta, but in terms of ratio of sides, it will become hypotenuse by base. Cot theta is reciprocal of tan theta. So the value will become base by perpendicular. Now we understood the basic concept, basic terminology, although there are some other things that we need to discuss. Now this table, this is the most important part of this chapter. In the last chapter, I told you that in your rough sheet, in your final board exam, you are going to do one thing. You are going to create this table first, because this table will be very helpful for you. Of course, you can expect 1 5-mark problem from this chapter. Also, there can be some problems which may come in 1 or 2 marks. So almost around 7 marks problem you can solve using this table. So this is very helpful. How to create this? Last time I told you the trick, this time I am telling again. As we can see that the most common angles that we are going to deal with in 10th class are 0 degree, 30 degree, 45, 60 and 90 degrees. Then these are different trigonometric ratios written in the first column. What is value of sine theta when theta is equals to 0 degree? What is the value of sine theta when theta is equals to 60 degree, 90 degree, 45 degree? So using this table, we can find that value easily. There is a trick to fill up this table. What is the trick? First thing, you are gonna write 0, 1, 2, 3 and 4 in front of sine theta. In each cell, you are gonna write these values. Okay, 0, 1, 2, 3, 4. Simple counting, whole numbers. Then you are gonna divide each value by 4. You can do that. Then you are gonna put under root. Done? Now, tell me one thing. What is 0 divided by 4? 0 divided by any number will always result in 0. Under root 0, 0 again. So this is gonna give us 0. So sine theta when theta is equals to 0 degree is 0. Then 1 by 4. 1 by 4 is 1 by 4, but under root 1 by 4 is what? Under root 1, 1. Under root 4, 2. So this is gonna give us 1 by 2. Correct? 2 by 4. We can simplify it further. It will become 1 by 2. But under root 1 by 2 will become under root 1 is 1. Under root 2 as it is. We don't need to use the decimal value 1.414. You can go with the root value also. So this is gonna give us 1 by root 2. 3 by 4 is simplified form, correct? So it will become under root 3, but for under root 4 is 2. So it will become root 3 by 2. 4 by 4 is 1. Under root 1, 1 only. This is gonna give us. Now, if you are done creating or putting the values in the first row of this table, then you can do one thing. You can just simply change the order of the numbers that you are getting in sin theta, and you can write those values here in this row of cos theta. Whatever value you are getting here in the last cell, you can write that value in the first cell of cos theta. So 1 we are getting, 1 I will be writing. Root 3 by 2 we are getting in the second last cell, so I will write it in the second cell of cos theta, root 3 by 2. 1 by root 2 and 1 by root 2 are in the same position. Then this 1 by 2, and then this 0 will come in the last cell. So we are just changing the order of the numbers, and then we are writing those values in the cos theta, for the cos theta, correct? Done. Now this is looking very clumsy, no? So let me do one thing, let me erase this and let me rewrite the values again. But you know the trick now, na? How to find these values? 0, 1, 2, 3 and 4. Divide all the values by 4 and put under root. Then that way you can easily find the values. This will be root 3 by 2 and this is 1. For tan theta is basically sin theta by cos theta, that we know, correct? So we are gonna divide these two. Sin theta by cos theta is gonna give us the value of tan theta. So 0 by 1, any number divided by 0 when divided by any number will result in 0. 1 by 2 divided by root 3 by 2. 2 and 2 cancel. What are we left with? 1 by root 3. 1 by root 2 divided by 1 by root 2, 1. Root 3 by 2 divided by 1 by 2, 2 and 2 cancel. What are we left with? Root 3. 1 divided by 0 is not defined actually. Why it is not defined? Because this is a fraction form, na? 1 divided by 0. Whenever we are writing any number in fraction form, suppose 3 by 5. So what is 3 by 5 basically? 3 by 5 represents that we are considering 3 parts out of total 5 parts, correct? If I am having a fraction 2 by 7, it is representing that we are considering 2 parts out of total 7 parts. How about this 1 by 0? Can we consider 1 part out of total 0 parts? No, we cannot. We don't know how to define this situation. So that's why as of now it is known as not defined. So this will be not defined. In short, I will be writing ND. Now, for cosecant theta is reciprocal of sin theta. So we are gonna do one thing. We are gonna find the value 1 upon sin theta. So again, 1 divided by 0, not defined. Then 1 divided by 1 by 2, it will become 2. 1 divided by 1 by root 2, so root 2. 1 divided by root 3 by 2, so it will become 2 by root 3. 1 divided by 1, 1. Secant theta is 1 by cos theta. 1 divided by 1, 1. 1 divided by root 3 by 2, 2 by root 3. 1 divided by 1 by root 2, root 2. 1 divided by 1 by 2, 2. 1 divided by 0, not defined again. Cot theta is 1 upon tan theta, reciprocal of tan theta. So this will become 1 divided by 0, again not defined. Then 1 divided by 1 by root 3, root 3. 1 divided by 1, 1. 1 divided by root 3, 1 upon root 3. 1 divided by not defined is gonna give us 0. So this you can find using this. 1 divided by 0 is not defined. So just transpose the values. So it is gonna give us 1 by not defined equals to 0. So this is 0. There is one more way to find these three values. Look at this. Whenever you are done finding the value of tan theta, so all the values of cot theta are nothing but these values written in the opposite order. Whatever the first value you can see here, it is the last value of cot theta. Whatever is the second value here, it is the second last value here. Third and third, they are same. Then second last, second. last, first, correct? Also, the same can be done for cosecant and secant theta. They are written in reverse order of each other. So this is how you can create this table, and this table is very useful. If you are not liking my handwriting, so let me show you this. Now looking very good, no? And you can easily create this. It will hardly take 5 minutes of yours, but this can ensure that you are getting at least 5 to 7 marks in your final exam, correct? So this is helpful, useful, and you will not get confused. Now, after creating this table, you will be very sure of what is value of which trigonometric ratios at what angle, correct? Even if you are very much aware of the value, but you can make sure you are remembering the correct answer. Okay. Now, before jumping into the problems, I will tell you the different terms that we are going to use in this chapter. First is height. Of course, this chapter is all about heights and distances. So we need to know what is height. Height is the measurement of an object in the vertical direction. So it means basically we are talking about the vertical distance of anything. If something is standing like this, then what is the distance between the foot of that object and the top of that object will give us the height of that object, correct? Now, and distance is the measurement of an object from a particular point in the horizontal direction. Again, suppose someone is standing here. This is a tower, huh? So someone is looking at the tower from a certain distance. So what distance is? The value of the horizontal path or distance in between these two, the person that is looking at the object and the foot of the tower. That is the distance. So it will be measured horizontally and the height will be measured vertically. Now, line of sight. Other than height and distance, we are gonna use this term, line of sight, or even if we are not using this, but still it will be there, maybe in a hidden way. Why? Because we are gonna talk about the top of something, the bottom of something. So to look at something, either we are gonna heads up or we are gonna heads down, correct? Whenever we are looking at something which is having more height than us, then we are gonna heads up, correct? So suppose this is the observer. If someone is looking at the high top of the tower, then that person is known as the observer. So this observer, if he is looking straight at, at the eye level, then this line is known as the horizontal line, horizontal level. As you can see here, this line is representing the horizontal level, the line that at which his eyes are. But if he is lifting his head up, then he is making some angle in between the horizontal and the line of sight, correct? Then this angle is what? This angle is known as angle of elevation, because he is elevating his head to just look at the top or wherever he is looking at. Now, these two terms we are going to use heavily. Then, angle of elevation of an object, I told you, is the angle formed by the line of sight with the horizontal level when it is above the horizontal level. Of course, we can look at something when it is having more height than us, correct? Then only we need to heads up like this. Now, the case when we raise our head to look at the object. Now, the other case can be what? Now, think someone is standing at the top of this tower. It is possible, no, that someone is standing at the top of this tower and he is looking at this observer. He is looking at this guy, or some object is there. Maybe a uh, football is there. Maybe basketball is there. So someone who is standing at the top of the tower is looking at the object or the observer at the ground level. Then his horizontal level is different now, correct? So this is the new horizontal level depending on where the observer is. Now, he is looking in this way, correct? He is not lifting his head up, he is actually looking at the object in this manner, where he need to uh, face down to look at the object. So the angle that he is creating with the horizontal level, the line of sight, the angle that they are creating is known as angle of depression now. So a value of this angle will always be given. If we are having a situation like this, then we must be given the value of this angle. But in case the observer is at the top and the object is at the ground level or at the sea level, then the horizontal level will change for the observer. Also, the angle of depression will also change. Now, one more thing I need to tell you. This horizontal level will always be parallel to the ground level. In any problem, if it is given that the observer is at the top of something, top of a building, top of a tower, or anywhere, is at a cliff or something, then the horizontal level of the observer can be different, but it will always be parallel to the ground level. It will always be parallel. This is very much useful because there we can apply the concept of two parallel lines and a transversal. We are gonna use this concept to find some angles, alternate interior angles and all. Now, the angle of depression is of an object viewed is the angle formed by the line of sight with the horizontal when it is below the horizontal level, because the horizontal level is now at the top of the tower. In case when we lower our head to look at the object, when we are lowering our head to look at the object, then we are not making the angle of elevation, we are actually making the angle of depression. It will always be known as the line of sight. The line or uh, the direction where we are looking at will always be known as the line of sight. Now, we are done with the terminology, correct? Step by step method how to approach the problems in this chapter. First thing, we need to draw a clear labeled diagram. Whenever you are given different scenarios, it may be regarding distance between an observer and suppose a tower, it may be regarding a cliff and boat example, it can be anything. If a problem is coming from this chapter, then the first thing that you will be doing is creating a very well labeled diagram. You are gonna explain everything, what label is representing which thing. Okay. Second step, you need to identify the angles which are given. Sometimes they are not given directly, they must be given in some hidden way. Okay, you need to identify them. Height, distance, if they are given, you need to identify them. Then choose appropriate trigonometric ratio. Of course, this is important. When we are given, suppose this scenario is given, this one, observer is here, tower is here, correct? Now look at this thing. The triangle that they are making is this, correct? We are talking about the uh, height and distance. We are not gonna include this line of sight in most of the problems. So we are dealing with the perpendicular because this is the angle of elevation, correct? So this is the side that is adjacent, so base. This is the side that is opposite, so perpendicular. So we are majorly dealing with perpendicular and base side, correct? So which trigonometric ratio we can apply here? We can go for directly tan theta or cot theta. So most of the time you are gonna use tan theta in your problems. Okay. So here we need to choose appropriate trigonometric ratio. If suppose in any problem either of the base or perpendicular is not given, but the length of hypotenuse is given, then you need to choose the trigonometric ratio accordingly. It can be sine, it can be cos. Most of the time we are going to deal with these three only. Then substitute the values because you know the value. Suppose angle is given and we are talking about tan 30 degree. So I'm going to do one thing. I will be looking at the table that we have created earlier. What is tan 30 degree? Okay, 1 by root 3. Okay, this is the value. I'm going to put that here. Then one value is known to me out of perpendicular and base. We can easily find the other value. Then substitute the values, solve the problem. and write the answer with the correct units also. This is also important. Sometimes we can find the numeric value, we can find the magnitude, but we will not write the correct unit. Examiner can deduce half or 1 mark from your answer sheet. So that's all about the introduction of this chapter. What are the basic things that you need, the table, how to create it, the basic terminology and everything. Of course, this is understandable, but still, if we are not solving problems based on these things, we are never going to understand the concepts clearly, correct? The first problem, the statement of the problem is the angle of elevation of the top of a tower from a point on the ground is 30 degree. Okay, the distance of the point from the foot of the tower is 10 meter. Find the height of the tower. So first we need to analyze the problem. What is given to us? Okay, what is given? The angle of elevation of the top of a tower. If we are talking about the angle of elevation, then observer is at the ground level, correct? He is not at the top of the tower. Then only he is able to create the angle of elevation. Otherwise, he would have been creating angle of depression. First thing, of the top of a tower from a point on the ground is 30 degree. So now we are gonna do one thing. First, we are gonna draw a tower. So here we don't need to actually draw the tower. We can go with the line segments. Okay. So as the height of the tower is not known to us, so we can roughly create one line like this. Why I am creating line like this, not like this? Why in a vertical manner, not in horizontal manner? Because a tower will always be like this only, no? So this is my tower now. Then this will be my ground level. You can use your ruler or scale and pencil or black pen to create this label diagram. Very neat and clean diagram you must be creating that will impress the examiner. Whoever is gonna check your answer sheet, na, he will get impressed because of the neatness of the diagram. Okay, no cutting allowed. Now, even if you are making any mistake, you can use the diluter or the whitener. Now we are having tower. The second point is that the angle of elevation of the top of the tower from a point on the ground is 30 degrees. So we need to consider one point. Suppose this point. So from this point, if someone is looking at the top of the tower, then the angle of elevation is 30 degree. So you need to join this point with the top of the tower using a ruler again. So this is A, this is B, and you're gonna write everything. AB represents tower. Okay, this point is point C. C is the point from where we are observing the tower, and the angle of elevation that is given to us is 30 degrees. So this is 30 degrees. You will write 30 degree here. The distance of the point from the foot of the tower is 10 meter. Now what is given to us? The distance of the point C, from the foot of the tower. Where is the foot of the tower? Point B. So this distance is 10 meter. So BC is given, not AB, correct? Because, and also not AC. So we need to find the height of the tower. So this is 10 meter. So you will write 10 meter here. Now you can do one thing. You can either directly go with AB, AC, BC like this, or you can give them some very specific name. As we need to find the height of the tower, what I will usually do is I will consider this to be H, height. Okay. Now let AB be equals to H. Analyze the situation now. Which trigonometric ratio should we apply here? Okay, what do we know? Angle we know, correct? In this triangle, look at this triangle ABC. This is 90 degree. Huh? This will always be right angle triangle. This is hypotenuse. This is base because this is the side adjacent to the given angle, and this is perpendicular. We need to find the value of perpendicular. We are given the value of base. So we can use this ratio, which is having a relationship between perpendicular and base. So which trigonometric ratio deals with perpendicular and base? Tan theta, correct? So we can use tan 30 degree and then we can find the value of h. What is tan 30 degree? So you need to write in triangle ABC. Tan 30 degrees is equals to perpendicular by base always. What is perpendicular? Perpendicular is AB or H, because we have given one very specific name to AB, that is H, divided by base is BC. What is the value of BC? 10 meter. So it is basically 10 H by 10. Do we know the value of tan 30 degree? I do remember it. It is basically 1 upon root 3. Even if you are aware of the value, but you want to be double sure that you are remembering the correct value or not, you can do what? You can look at that table that you have created in the rough sheet, correct? Using that table, you can easily tell the value of tan 30 degree, that is 1 upon root 3. So basically what we are saying is that tan 30, in place of tan 30, I will write 1 upon root 3, and this value is equals to h upon 10. We can do one thing, we can transpose this 10 to left side, so it will become 10 by root 3 is equals to h. Now this can be your answer. The height of the tower is 10 upon root 3, but usually we don't keep our answers like that, like this, where we are having an irrational number in the denominator. We can do one thing, we can rationalize this. Rationalize how? We are going to multiply the whole value by root 3 by root 3. That will not change the overall value of the equation, and also it will look nice. So when we are multiplying this value, so h is basically 10 upon root 3, correct? Multiply and divide with root 3. So h value will become 10 into root 3, 10 root 3. Root 3 into root 3, 3 meter. So this is your answer now. So height of the tower, in the end, you will write it like this. The height of the tower is 10 root 3 divided by 3 meters. This will be your final concluding statement. Whatever is asked, you need to write that very clearly. Okay? This is very easy problem. I will be starting from very easy problem to a difficult one. Okay? Second problem. The angle of elevation of the top of a building is 45 degrees. The distance from the building is 20 meter. Find the height. So again, similar type of problem. What is given to us? The angle of elevation, it means the observer is at the ground level. Of the top of a building is 45 degrees. So let's consider a building. So this line segment AB is representing the building. This is my ground level. Now, the angle of elevation of the top of a building is 45 degree. So now, there is a point, suppose this one, from where the angle of elevation of the top of the building is 45 degrees. So this value is 45 degrees. This is my point C. Now, the distance from the building is 20 meter. So it means B and C are 20 meters apart. We need to find the height again. So I can consider value of AB to be h. So you are gonna write everything. AB represents tower. Then C is the point from where we are observing the tower. the tower. Also, given angle of elevation is 45 degrees and the distance between B and C is 20 meter. Now, in the next line, you will write let AB be equals to H. Again, one angle is given and the side adjacent to that angle, the value is given 20 meters. Side opposite, we need to find the value of that side. So, with which trigonometric ratio should we go with? We should be going with which trigonometric ratio? We are dealing with perpendicular and base only. So, again we can go with tan theta, correct? So, here in this case, theta is 45 degrees. So, in triangle ABC, tan 45 degrees is equals to perpendicular by base. Perpendicular here is AB, base here is BC. AB is H, BC is 20. Now, do we know the value of tan 45 degrees? Yes, we know the value of tan 45 degree. It is 1. But just to be double sure, we can just look at the table that is that we have created at the back of the answer sheet in the rough sheet, correct? So, from there we are sure that the value of tan 45 degree is 1. Now, 10 in place of tan 45, I will write 1 and this h by 20 will remain as it is. Now we just need to do one thing. We just need to transpose this 20 to right side. So, from here we can find that the value of h is 20 meters. In the end, you will conclude your answer by writing that the height of the given tower is 20 meters. And please don't forget to mention the correct dimension. Okay, sorry, correct unit. So, this is how you can approach this type of problems. Now, this time we are gonna see a problem where we need to apply the logic differently, a little bit. Now, from the top of a cliff 50-meter high, so it means we are talking about a cliff which is having a height of 50 meters. The angle of depression of a boat is 30 degree angle of depression. This time we are seeing a new term, correct? Angle of depression. When can we create angle of depression? When observer is at a higher distance vertically than the object, correct? Observer is at a higher distance or is at height or more is sitting at the top of something and looking at the other object by lowering his head, correct? So, someone is looking at the boat from the cliff. The angle that he is making with the horizontal level is 30 degrees. Find the distance of the boat from the foot of the cliff. Okay. First thing, we need to create the cliff now. So, here I will do this. Suppose this is the cliff. This is the top of the cliff. This is the water level or ground level. Now, the height of this cliff is given as 50 meters. So, I will write 50 meters. This I will consider as A, this point as B. You can go with any name, but usually we go with A and B. Now, the angle of depression of a boat is 30 degree. So, the horizontal level here is different now. So, this is the horizontal level. Correct? Suppose boat is somewhere here. So, line of sight will be like this. So, this is 30 degree, the angle of depression. This angle is given to us. Suppose this is point C. I told you initially that if angle of depression is given, then horizontal level will always be parallel to the ground level or water level. Correct? If these two lines are parallel, suppose this is P. If AP is parallel to BC, then AC will act as a transversal. Correct? You need to write it like this. First, you are gonna define everything. AB is representing cliff. Sorry, cliff. Then C is the point where boat is. Then AP is the horizontal level. Now, now AP and BC are parallel to each other. Also, AC is acting as a transversal. In between two parallel lines, if a line is acting as a transversal, then they will be creating some very specific angles. Those angles can be equal to each other, right? Now, look at this and this line. This AC is acting as transversal. So this angle and this angle, are they equal? Yes, they are. So you will write, therefore, angle C is equals to 30 degrees because these two angles are alternate interior angles. In case of two parallel lines and a transversal, alternate interior angles are always equal to each other. Then you will write 30 degrees here. Now we are sorted. I can see one triangle ABC. Okay, one thing I know, angle I know. We need to find the distance between the foot of the cliff and the boat. So basically we need to find the distance of BC. Let us consider BC to be x. I will usually use h for heights and x for horizontal distance. Okay. Let BC is equals to x. Now, in triangle ABC, ABC it is. Again, we are dealing with perpendicular and base. So I will use tan 30 degrees. Tan 30 degrees is equals to perpendicular AB by base BC. AB by BC. AB is equals to 50 meters. So 50. BC is equals to x. What is tan 30 degree? If you know the value, well and good. That is 1 by root 3. If you don't know the value, look at the table that you have created. Now, we know the value of tan 30 degree. So it will be 1 by root 3. 1 upon root 3 is equals to 50 by x. So we can transpose the value. X will come on the left side. Root 3 will go to the right side. So x will be equals to 50 into root 3 meters, whatever unit is given to you. So here it is given as meters. So the distance between, concluding line, the distance between the foot of the cliff and the boat is 50 root 3 meters. No need to rationalize here because the irrational value is written in numerator, correct? So this will be your final answer with concluding line. Please don't make any crossing mistakes or any cutting and anything. Create very neat and label diagram. Tell everything what you are considering to be. If AB is the cliff, AB is cliff, right? If C point is showing the position of the boat, boat it is, the angle of depression and everything. So you need to create very well labeled diagram and label you need to explain. Then you can find the answer accordingly. And one thing you can use that is very useful is the table that you have created. Now, fourth problem. The angles of elevation, now look at the term, not angle of elevation, angles of elevation. So here we are talking about multiple angles. The angles of elevation of the top of a tower from 2 points, correct? Then only we are having two angle of elevations on the same side of the tower and in the same straight line are 30 degrees and 90 degrees. This is very important. We are talking about 2 points, so it can be anywhere on either side of the tower, correct? Anywhere. Now, in the problem, it is given that they are on the same side of the tower. Okay. Also, they are in a straight line. Then, the angles are 30 degrees and 60 degrees respectively. If the distance between the 2 points is 10 meter, okay, find the height of the tower. This is very interesting problem. This type of problems you can expect in your final exam. The first three problems are just for the base, just to let you know what to expect or how to approach the problem. But this type of problems can appear in your final exams. Okay. First thing, we need to create tower. Now, this is my tower. This time we are dealing with 2 points. So two angle of elevation. So I will create the ground first. And please do use scale, ruler and pencil or black pen. Now, this is my tower. Let me name it as AB. 2 points we need to consider. So, first, second. Now, the angles are 30 degree and 60 degree. Now, this is point C, this is point D. Okay, let me ask you one thing. Which angle is 30, which angle is 60? If we are looking at the angle from a very far distance, then the value of the angle is lower. So this is 30 degrees. Correct? If I'm going towards the tower, then I will be elevating my head. Correct? So more angle I am creating. So this will be 60 degrees. Now, if the distance between the 2 points is 10 meter, okay, which 2 points? Which 2 points are we talking about? BC, CD, DB? The 2 points from where we are looking at the top of the tower. Those 2 points. So it means the 10 meter is the distance between C and D. 10 meters only, no? Yeah. So this distance is 10 meters. This distance is not given to us, the height is not given to us. Find the height of the tower, and we need to find the height of the tower, that is AB. Correct? As I told you, in case of heights, I will always use the variable h. But also we need to deal with this distance also, no? So I will use x for this distance. Again, we are gonna do one thing, the approach, how to approach this type of problem. See, using triangle ADB. ADB is also a right angle triangle. I can find the value of 1030 degrees, correct? That way I will be creating a relationship between the height of the tower and this total distance. Then using triangle ABC, I can again use 1060 degree value, and that way I will be creating a relationship between the h, this height and this distance. Now in these two equations, one thing is common, that is value of height. Then we can substitute the values accordingly. We will be getting a value of x. Using the value of x, we can find the value of h. That will be my approach. Now, first thing, you're gonna do one thing. In your exam sheets, you will be writing AB represents tower. C is the point from where we are looking at the top of the tower, and the angle of elevation from point C is 60 degree. D is the point from where we are looking at the tower, top of the tower, and the angle of elevation is 30 degrees. Also, the distance between C and D is 10 meters, given part. Now, we are considering the height of the tower or AB to be h. Then you will write the distance between the foot of the tower and point C we are considering to be x. After writing everything, after explaining your figure, you will do one thing. You are gonna write in triangle ABC. In triangle ABC, we can apply 1060 degree, correct? Because we are dealing with perpendicular and base. So 1060 degrees is equals to perpendicular AB by base BC. So I am directly writing, but in your exam sheet, you will write everything AB by BC, then you are gonna substitute the values. Now 1060 degrees is what? Root 3. But if you are not sure and if you want to be double sure, you can look at the table that you have created. So this is root 3 is equals to h by x. From here, I can do one thing. I can find the value of h. H will be equals to x into root 3 meters, or no need to write the unit here. This will be my equation number 1 because we are not getting any particular magnitude here. So I will call it my equation number 1. Then I will look for triangle ABD, the bigger one, this one. In this triangle, we are having the value of angle of elevation 30 degrees. Also, we know this distance DC. X, we already assumed that this is the distance between B and C. And H we need to find, so we will go with H. So 1030 degrees is equals to perpendicular AB H by base BD. What is the total length of BD? This value we know, 10 meter. This value we don't, but we assumed it to be x. So the total distance between B and D is what? X plus 10 meters. So you will write x plus 10 here. Now 1030 degree value is 1 by root 3. Not sure? Look at the table. 1 upon root 3 is equals to h by x plus 10. Now you can transpose this x plus 10 to left side. So from here we can get the equation in terms of h as x plus 10 divided by root 3. This is equation number 2 now. Now we are having two equations in terms of h. So both are values of h only. So we can equate them. So you will write like this. From equation 1 and 2, x root 3 is equals to x plus 10 by root 3. Transpose this root 3 to left side. So it will become x root 3 into root 3 square, that will be 3. So it will become 3x equals to x plus 10. This x I can bring to left side. So it will become a negative term. So 3x minus x, 2x. So this is gonna give us 2x equals to 10, or simply x equals to 5. So the distance between C and B is 5 meters. But our work is not done because we need to find the height of the tower. So I can use the relationship. Which relationship? Either this one, either this one. So this one is looking simpler, no? So I will go with equation number 1. In equation number 1, put value of x. So this is gonna give us x into root 3, or simply h is equals to 5 root 3 meters. Now you are gonna write concluding that the height of the tower is 5 root 3 meters. So this way you can approach this type of problems where two angle of elevations are given, the distance between the points are given, not the distance between one point and the cliff, or sorry, the foot of the tower, and also the height is not given, but still we can solve this, correct? So we are gonna create a relationship, we are gonna equate the equations. That way we will be getting value of one of the variable. Using that value we can find the value of the other variable. So that will be our approach here. Now, fifth type of problem. This problem did appear in board's exams once. Now, the statement is the angles of depression, again angles, so it means more than one angle. The angles of depression of the top and the bottom of an 8-meter tall building from the top of a multi-storied building are 30 degrees and 40 degrees. Very lengthy statement, but what is given here? We are given two buildings. One is a small building. The height is given of this building as 8 meter. Okay, this is 8-meter tall building. Then second building is multi-storied building. So the height would be, we don't know as of now. But according to the first line, someone is standing or someone is looking at this building from the top of multi-storied building. So if someone is looking at the top of this smaller building from the top of this multi-storied building, then the angle of depression that he is creating, so angle of depression means this is the horizontal level now, correct? So the angle that he is creating is 30 degrees. If he is looking at the top of the building, smaller building, from the top of multi-storied building, then the angle of depression is 30 degree. But he is also looking at the bottom of this smaller building. So now the angle of depression that he is creating is different. It is 45 degrees. So this angle is 45 degrees. Now, find the height of the multi-storied building. So we need to find the height of this building and the distance between the two buildings. We need to find the distance also. You don't need to create these type of buildings in your exam. This is just for your imagination. I just wanted you to understand the situation, what is happening here. The kind of diagram that you will be creating or kind of figure that you will be creating will look something like this. Here, this PC is representing the multi-storied building. One second. AB is representing the smaller building. The height of AB is 8 meters. Now, and you are gonna write everything in the answer sheet like this, that PC is representing multi-storied building. AB is representing the smaller building of height 8 meters. Then the angle of depression, this PQ is horizontal level now. Now the angle of depression or the value of QPB represents the value of angle when the observer is looking at the top of the smaller building from the top of the multi-storied building, and the value is 30 degrees. Also QPA represent the angle of depression when the foot of the smaller building was observed by the observer from the top of the multi-storied building. So this will be your diagram. Also you can join B with D and A with C. So to close this figure, we need to find two things here: value of PC and value of AC. But before that, we need to analyze some situation here. Horizontal level PQ is parallel to BD. Why? Because BD is parallel to the ground level, correct? This line that we are creating is parallel to this ground level AC. Now, this will be what? This will be rectangle, correct? And the opposite sides of the rectangle are what? Equal. So if it is 8 meters, then DC is also 8 meters. One thing. Also, BD and AC are parallel. We know that horizontal level is always parallel to the ground level. So PQ is also parallel to BD. Now, if these two lines are parallel, PQ and BD, then PB will act as a transversal now, and the angles they are creating must be having some very specific relationship. So this angle and this angle, they are alternate interior angles, so they are equal to each other. So this angle is also 30 degrees. Same goes for PQ and AC. They are parallel lines and PA is acting as a transversal. So it means this angle and this angle, they are equal because they are alternate interior angles. Now observe two triangles now, PBD and PAC. In these two triangles, what do we know? We don't know the height of this or the length of this PD. So we will assume it to be H. We also don't know the length of AC or the distance between the two buildings. So we will consider it to be X. But we know the value of this 8 meters, and because of this we know the value of DC also 8 meters. How to find the height or the distance now? First we are going to consider this triangle PBD. So I will write in triangle PBD. We are talking about the perpendicular and the base of this triangle, correct? So if AC is X, then BD is also X, correct? Because they are equal. So in triangle PBD, tan 30 degrees is equals to PD or H by BD or X. Value of tan 30 degree is 1 upon root 3. 1 upon root 3 is equals to H by X. You can transpose the values and you will realize the value of X is root 3 H. This is equation number 1. Now look at this triangle, the bigger one, PAC. In this triangle, we can find the value of 1045. Although one part of this total height is known to us, but this is completely not known. Still, we can create the relationship. So 1045 is equals to PC, that is H plus 8 meter total height, divided by AC, that is X. Value of 1045 degree is what? 1. Not sure? You can look at the table, that is 1. So 1 is equals to H plus 8 by X. Transpose this to left side. So value of X is H plus 8. This is equation number 2. So in equation number 1, we are having one value of X. In equation number 2, we are having the other value of X. We can equate them. Yes, we can. So we are gonna equate the values. So you are gonna write from equation 1 and 2. Root 3H is equals to H plus 8. Now you can do one thing. You can transpose this H to left side because they are like terms. So it will be root 3H minus H is equals to 8. We can take H common. So it will become H into root 3 minus 1 is equals to 8. From here, the value of H that we are getting is 8 divided by root 3 minus 1. So the value that we are getting is H equals to 8 divided by root 3 minus 1. So I'm going to use the next slide for this one. So H is equals to 8 divided by root 3 minus 1. You can stop here, but as I told you, if you are having any irrational value in the denominator, so you can do one thing, you can rationalize the denominator. How to rationalize this? We can multiply and divide the same number with root 3 plus 1. Root 3 plus 1. Now, 8 into root 3 plus 1, same value. 8 and in brackets, root 3 plus 1. But here what is happening? A minus b into a plus b. A square minus b square. So root 3 square, 3 minus 1 square, minus 1. This will become 2. So H is 8 into root 3 plus 1 divided by 2. We can cancel. So value of h will be 4 into root 3 plus 1. This is your height of the tower, of the multi-storied building. So now you can write that the height of the multi-storied building is 4 into root 3 plus 1. But is our work done? No, because we need to find the distance between the two buildings. We need to find this also. So one relationship we know, that x is equals to root 3 into h, correct? We know the value of h, so we can directly use this. So okay, this piece I'm gonna use. X is root 3 into h. So it will be x is equals to root 3 into 4 into root 3 plus 1. So I can directly take this root 3 and will multiply with values that are inside the bracket. So it will become root 3 into root 3. So the x value will become 4 as it is inside bracket. Root 3 into root 3 square, that is 3, plus 1 into root 3 meters. So this will be your distance between two buildings. So you are going to conclude it like this. The height of the multi-storied building is 4 into root 3 plus 1 meters, and the distance between the two buildings is 4 into 3 plus root 3 meters. So this is how you can solve this type of problem. This problem, if you are solving this type of problem, it will give you confidence. You are gonna solve every other problem. These problems are easy. You just need to practice how to approach the problem. Then they are very easy to solve. You are just doing the basic calculations here. Now, next problem. At a point on the ground level, the angle of elevation of a vertical tower is found to be such that its tangent is 5 by 12. I don't know why I am saying target. Now, this is a very different type of problem. Here, what is not given to us? The value of angle is not given. Instead, in the statement of the problem, it is saying that the tangent from a particular point, the value of the tangent is 5 by 12. So we need to analyze this line. Also, on walking 192 meters towards the tower, the tangent of the angle of elevation is 3 by 4. Again, the value of the angle is not given, but the value of tangent is given from other point when we are walking 192 meters towards the tower. Find the height of the tower. So the figure would look something like this. Here AB represents the tower. D is the first point from where we are looking at the tower. Okay. The angle is not known to us, so I will consider it to be theta. But whenever we are looking at the top of the tower from point D, the tangent value that it is making is given, that is 5 by 12. How to use this, I will explain. Then the same person is moving towards the tower by a distance of 192 meters. Now, he is making different angle now, correct? But still, the value of the angle is not given. Instead of that, the value of tangent is given again, that is 3 by 4. And we need to find the height of the tower. So again, I will do one thing. We need to find the height. So I will consider the height of the tower to be h. And this distance is also not given, na? BC. So I will consider it to be x. As I told you that vertical distance, I will consider h and horizontal x. Now, how to solve this problem? First thing, again we are dealing with perpendicular and base values, na? So we are gonna go with tangent. And also this is more important for us to use tangent because the tangent of those angles is given, that is 5 by 12. So if I am looking at triangle ABD, after writing everything for you, I am explaining again. You are gonna explain what is what. AB is the tower, D is the first point from where the observer is looking, and the tangent is 5 by 12. Then C is that point where that he is looking at the tower after coming 192 meters towards the tower. So after writing everything, you are gonna write in triangle the first one, ABD. Tan theta, because the angle that we are considering is tan theta. Tan theta, what is the value of tan theta? Perpendicular by base. Perpendicular is h, but base is this BD. Total length would be x plus 192 meters. Now, we don't know theta. How to find the value from the table then? No need to use the table in this type of problems because tan theta value is already given, that is 5 by 12. So you can directly put value of 5 by 12 in place of tan theta. So the equation will become 5 by 12 is equals to h by x plus 192. Cross multiply. Of course, I want the whole equation to be in terms of h. So I will just only transpose this x plus 192 to left side. So the equation will become 5 into x plus 192 divided by 12 is equals to h. This will be my equation number 1. Okay, this is my equation number 1. Now, second triangle, triangle ABC. In triangle ABC, again the value of tangent is given. So, in triangle ABC, tan beta is equals to side opposite or perpendicular AB, that is h, by base BC. Tan beta is given 3 by 4. H as it is by x as it is. Transpose this x to left side. So the equation will become 3x by h. Oh, sorry, 3x by 4. My bad. This is not h. This is 4. 3x by 4 is equals to h. This will be your equation number 2. Now you are having two equations in terms of h. We can equate them. Correct? So from equation 1 and 2, let me use this space. From equation 1 and 2, we can see that the first equation is 5 by 12 into x plus 192. So 5 into x plus 192 by 12 is equals to 3x by 4. 4 and 12 are cancelable by 3. 3 I will transpose to right side. So the equation will become, I will open the bracket, 5 into x, 5x plus 5 into 192, that would be 0, 0, 45, 16459, 960 is equals to 3 into 3x, 9x. Transpose this to right side because they are like terms. So it will become 960 is equals to 9x minus 5x, 4x. So value of x would be 960 by 4. That is x is equals to 240 meters. So the distance between point B and point C is now known to us, that is 240 meters. But still we need to find the height of the tower, correct? So is there any relationship between h and x? So this one is the easier to use, although there are two. No, you can go with any, but I will choose this one, easier to solve. 3x by 4 is equals to h. So in equation 2, put value of x. Therefore, h is equals to 3 into the value 240 divided by 4. These are divisible by 60. So value of h would be 3 into 60, 180 meters. Now you can conclude the problem by writing that the height of the tower is 180 meters. So this is how you can approach this type of problem. If the value of angle is not given, but the line is given like this, that the tangent is 5 by 12 and tangent is 3 by 4, then again you can do one thing, consider the angles to be alpha beta, theta beta, anything. Then you can do one thing, you can replace the tan theta with this value, tan beta with this value. They are usable. So please don't get confused that the angles are not given, how to approach this problem. Again, everything is given. Now, next problem. This one is also one of the problem that appeared in the exams. A straight highway leads to the foot of a tower. Okay, as you can see, there's a tower and straight highway where the car is running leads to the foot of the tower. A man standing at the top of the tower observes a car. Okay, someone is here at the top of the tower and he is observing the car, uh, at top of the tower observing a car at an angle of depression of 30 degrees. So the angle of depression he is creating with the horizontal. So this angle is 30 degrees when he is looking at the car, which is approaching the foot of the tower. So it is moving in the direction of the tower. Now with a uniform speed. So this is very important. So the speed is not changing. 6 seconds later, the angle of depression of the car is found to be 60 degree. So the time taken by car from moving from this point to this point is 6 seconds. And the car is moving at a very uniform speed. So speed is not changing. Also, the angle of depression that the man is making with line of sight and the horizontal level is 60 degrees. Now, find the time taken by the car to reach the foot of the tower from this point. What is the major problem here? Angles are given, but no distance is given. Nothing. Not the height of the tower, no distance between car and the tower, or the distance between the cars also. Nothing is given in terms of distance. But one thing is given, that the time taken by the car from this point to this point is 6 seconds. Can we use this? Of course, we are going to use this because we need to find the time taken by car to reach the foot of the tower. So from this point, how much time it will take to reach the foot of the tower? That we need to find. Let me ask you one thing. The car is moving at a uniform speed. Speed is not changing. Correct? Now, whatever time it took from reaching from this point to this point, if somehow we are able to create a relationship between this distance and this distance, then we can find the time taken by the car reaching from this point to the foot of the tower in a relative terms, correct? Because the speed is not changing. So we are going to use this approach only. We are going to do one thing. First, we are going to create a very neat label diagram, not this one. So this is the diagram. AD is representing the tower, BD is representing the, B is the position where the car was initially when the observer was looking. C is the point where he is looking at the car at the second time. The B and C, the distance, the car that is covering, the car is taking 6 seconds. Then we need to find the time taken by the car in covering the distance between C and D. Also, this angle and this angle, they are alternate interior angles, they are equal. This angle and this angle, they are also alternate interior angles, they are also equal. Now, if these are equal, so look at this triangle ABD. In triangle ABD, first we almost forgot this. AD I will consider as H. No distance is given, so I will consider the BC to be X and CD to be Y. This time one new variable we are using, Y. So now, if somehow I will be creating a relationship between X and Y, I can easily tell the time taken by the car from this point to this point, correct? Now, look at this. In triangle ABD, tan 30 degrees is equals to perpendicular or H divided by the base, that is BD. So total length is X plus Y. Now, tan 30 degrees, I know 1 upon root 3 is equals to H by X plus Y. Then you can transpose. So x plus y is root 3 is equals to h. This will be your first equation. From where we can get the equation number 2? From the second triangle ACD. So in triangle ACD, tan 60 degrees is equals to perpendicular, that is h, by base, that is CD. Or now tan 60 degree is root 3 is equals to h by y. We can transpose, so it will become y into root 3 is equals to h. This will be equation number 2. From this equation, we can, and this equation, I can see that we are having two values of h. We can equate them. So next slide I will be using. From equation 1 and 2. So what are we having? X plus y by root 3. X plus y by root 3 is equals to y into root 3 or root 3y. Now transpose this root 3 to right side. So root 3 into root 3 will become 3. So x plus y is equals to 3y. Transpose this y to right side. So x will become 3y minus y, 2y. Now look at this. X, this was the x value, no? This is y and this is h. X distance is twice as that of y, correct? Or simply y is half of x. The car is moving at a very uniform speed, correct? Time taken by the car in covering x meters is 6 seconds. So to cover x meters, car is taking 6 seconds. Now to cover 1 meter, how much time it will take? 6 by x, unitary method. To cover 1 by 2 of x meters, how much time will it take? 6 by x into 1 by 2 of x. X and x are going to cancel each other. 2 can cancel 6, so it will be 3 seconds. So to cover a distance of half of x meters, it is going to take 3 seconds. So y is equals to half of meters. So the time taken by the car from point C to reach the foot of the tower is going to be 3 seconds. This will be your final answer. So this is how you can approach this problem. No distance was given, correct? Only angles were given. So we are going to create the relationship, and using unitary method, you can find the final answer. So 3 seconds would be your final answer. So we are done with different type of problems that you can expect in this chapter. One more thing we need to consider: case study. Recently, CBSE has been giving case studies in different chapters, for different chapters. So for this chapter, I will be showing you case studies. If you are getting a problem related to case study, you should be feeling lucky, because they are more than easier to solve. So first we need to understand the situation that is given to us in the case study. In this case study, a group of students of class 10th visited India Gate on an education trip. The teacher and the student had interest in history as well. Okay. The teacher narrated that India Gate, officially named Delhi Memorial, originally called All India War Memorial, and monumental sandstone arch in New Delhi. So previously it is having a different name, now it is having a different name. Dedicated to the troops of British India who died in wars fought between 1914 and 1919. So it is a war memorial dedicated to those soldiers who were fighting for British India when India was not independent. Now, the teacher also said that India Gate, which is located at the eastern end of the Rajpath, formerly known as Kingsway, So it is also having two different names, Rajpath and Kingsway, is about 138 feet or roughly around 42 meters in height. So the height of India Gate is 42 meters. This is the scenario, this is the case study, and based on this case study, CBSE will giving you some problem. Problem number 1. What is the angle of elevation if they are standing at a distance of 42 meter away from the monument? To solve these problems, you are going to do one thing. You are going to quickly create a diagram. Suppose here I will be creating the India Gate. This is India Gate. So height of India Gate is 42 meters as given here. Because we are dealing in meters now, so that's why I'm using meters value. If it is given in feet, I will be using this one. Now, suppose this is point A, B. Now, we need to find the angle of elevation. So, suppose the group is standing here at point C. The distance between them and foot of the India Gate is 42 meter. We need to find the value of this angle. Suppose this is theta for now. Now, we can easily find the value of this angle using the ratio between this side and this side. So, this is about perpendicular and base. Again, we can go with tan theta. So, tan theta is AB by BC or 42 by 42. 1. So, tan theta is 1. For which angle, for what value of theta, tan theta is 1? Tan 45 degree. So, we can replace this with tan 45 degrees. So, both the trigonometric ratios are equal. So, it means the angles are also equal. So, theta value is 45 degree. So, you can easily select B option. That is your answer, 45 degrees. Done with one problem, 1 marks you will get. Next one. They want to see the tower at an angle of 60 degrees. Okay, this is degrees. Huh? So, they don't want to know the distance. So, they don't want to know the distance where they should stand and hence find the distance. Okay. They are not having any idea where they should be standing, so that they will be watching the India Gate at an angle of elevation of 60 degrees. So, this time what is given to us? The angle of elevation. So, this is India Gate. This angle should be 60 degrees. ABC. This is where the group is standing. Now, the height of the India Gate is again 42 meters. We need to find the distance of BC. So, again tan 60 degrees should be equals to AB 42 by BC. Suppose BC is X as of now, X. Tan 60 degrees is root 3. Root 3 equals to 42 by X. Cross multiply or transpose, X is equals to 42 by root 3. Now, the value is not matching. We know that the value of root 3 is 1.73, correct? So, if we are dividing 42 by this value of root 3, so okay, this is 2.24 guys. So, this will come roughly around 24.24 meters. We need to write the values into decimals, so this will be your correct answer, 24.24 meters. Then next problem. If the altitude of the sun is at 60 degrees, then the height of the vertical tower that will cast a shadow of length 20 meters. This is important, this type of problem. Whenever we are talking about the shadow because of sun, or it is given that the sun is at the altitude of 60 degree. So basically what we are talking about, suppose this is one tower, because we are talking about the tower, no, one vertical tower. Suppose sun is here somewhere. So whatever angle that is given in with respect to sun, the shadow will be creating that much angle only. So this is the shadow of the tower and this is the line of sight. Okay. So the angle will be same, that is given here 60 degrees. Now the height of the vertical tower that will cast a shadow of length 20 meters. It means the length of shadow is given 20 meters. So A, B, C. We need to find the height of the tower. So I will consider it to be H. Again tan 60. H by 20. 1060 is root 3 h by 20. Then value of h is 20 root 3 meters. These are very small problems. You can easily find the answers. Just apply the basic logic and you can score easily in case studies. Fourth problem, the ratio of the length of a road and its shadow is 1:1. Okay. The angle of elevation of the sun is, okay. Again, when we are talking about the angle of elevation of sun, then it will be same as of this angle, the angle made by the shadow and the line of sight. Suppose ABC. So basically we need to find the value of this angle theta. What is given? The ratio of the length of the road. Suppose this is the road, huh? The length of this road and its shadow is 1:1. If this is x, then this is also x. They are of equal value. Then we need to find the angle of elevation of sun. Okay. What is angle of elevation then? So tan theta is equals to x by x, right? Perpendicular by base. 1. Tan theta, for which value of 10 it is 1. 1045. So tan theta is equals to 1045 degrees. So theta is equals to 45 degrees. So answer is option B. Now, last one. The angle formed by the line of sight with the horizontal when the object viewed is below the horizontal level. What is the name of the angle? The angle formed by the line of sight with the horizontal when the object viewed is below the horizontal level. So someone is standing at the top of a tower. This will be their horizontal level and object is here at the ground level or below the height of this tower. Then if someone is looking at this object, so the angle that they are creating with the horizontal level is known as what? We know this, angle of depression. So the correct answer is angle of depression, option C. So this is how you can approach different type of problems in this chapter. Also, how to solve them I told you, and one more thing, remember that you are gonna create the table first. That will be very much helpful. Now the approach we know, how to solve them and everything. So we are done with this session. The case study is very easy, correct? Easier than the problems, and you can easily score 1 mark, 5 marks, because each part will be of 1 marks in case study. So we are done with the chapter and we are done with this session. If you are still having any doubt, any problem related to this chapter, you can let us know in the chat box or comment section. So we'll meet you in one more session with one more chapter. Till then, bye bye. Take care of yourself, and let's summarize this chapter. We have seen the prerequisite where we talked about the trigonometric ratios and everything from the previous chapter, and then we found we understood the concept of height and distances, different terminologies, and how to solve different problems. So yes, we are done. Thank you for joining the session. We'll meet you soon. Till then, bye bye, and I will end this session for now. Thank you.